Uno momento. I will turn the heat down just a little bit. I have it all the way up. People are complaining. Okay, so before we begin, what do you want to start with? Quiz 1, quiz 2, quiz 3? What are we going to do?
I think 3.
3 for sure?
Mm-hmm.
Okay. Do you all want to copy a quiz 3 or do you want to use the one I gave you earlier? Did I give you one earlier?
No.
Oh,
You're
here.
going to have 3 copies.
Perfect amount. Quiz 3. Okay. Do you need a pen?
Yeah.
Here, I got you a pen. Here. It's got some ink in it. Give it a try. Sorry. Alrighty. So, quiz 3. In the flesh for our live studio audience. You guys want to see the first page? What do you want to do? It's your show, guys.
No.
No first page. Skip the first page. Hey, what's up, kid? Oh, what's up? Hi. You brought a friend.
Who is that?
I can't tell you, that would be against the code of conduct.
Oh.
Hello. I can't hear you, but
It's
that's
me,
totally...
guys.
Oh,
And Daddy.
now we can hear you.
Hi.
Hi, Addison. We decided to skip the first page. Is that okay, or do you guys want to see the first page?
That's okay. I'm going to
sure?
turn my camera off.
Okay, that's less awkward. Thank you. All right. So, page 2. And again, make sure you're answering in the chat whether you want to see page 2 or not. Kids that are here, would you like to see page 2?
I don't think I need to.
No. Joseph, how are you feeling? You feeling pretty good about that? Okay. Kelly, feeling good about page 2? Addison?
What?
Yeah? Okay. Skipping page 2. Page 3.
Yes.
I hear a yes. All right, let's do it. So, check it out. Same logic as before. We're just thinking what number, and I'll zoom in. And I need to look at me, not you in the screen, because now I can't really see what's going on. So, is that the button I want to hit? I can't read. Show in a tile. Minimize, pin. Can I make this big? Yeah, I'd like to make this big mode. Please. I want to see myself. Okay, fine. I can't do it. That's fine. All right. So this guy right here. What number, when you divide it by 4, is 7? Well, here's the logic I use. When I take this number and divide it by 4, I get 7. Because if I divide this by 4, the 4's divide out, and I get 7. So what number is this? 28. So I know that x minus 5 is 28. So what number minus 5 is 28? Here's my logic. This number, when you take away 5, is 28, right? Because if I take away 5, 28. What number is that? 33. Because adding 5 is the same thing as adding 2, then adding 3. If I add 2, then add 3, it's clearly 33. How we feeling? Gucci? Wonderful?
Mid.
Mid. Why mid?
I think I got it.
For sure?
Yeah.
Do you feel okay about the logic here? Maybe you just knew 28 divided by 4 is 7, right? You could just write 28 is x minus 5.
I think I've been able to do that one, but it's so confusing me when I do it.
Yep, you just got to slow down. If you need to, cover it up with your finger. 3.14, find r if 3 times the quantity of r minus 2 is 18. So 3 times something is 18. It's 6, right? If you didn't know that, you could write this, because when you times that by 3, you get, right, 18, which simplifies to 6. So we know that r minus 2 has to equal 6. So what number minus 2 is 6? 8. If you wanted to, you could think it's 6 plus 2 minus 2 is 6, right? So that's 8. I don't know. What do you think? Yeah, for sure? Okay. Let's go here. Solve each of the following equations, and there's only one of them because this is part 1. Part B and all that other stuff is more advanced, so they're on a different section. This right here. Something is what I'm going to cover up there. Minus 4 is 17. Well, clearly what I need is this number so that when I take away 4, I get 17. What number is this? Looks like 21 to me, right? 3 and 1. If you add them one after the other to 17, you get 21. So I know 3x has to equal 21. So x is going to be 7. Because 3 times 7 is 21. Kelly and friend, how are you feeling? Oh, God, it's just like COVID. Yeah, we'll tune in. And now they're rowdy.
No. Can you hear
Doubt
me?
it.
Can you hear me?
This is pre-recorded. Don't even try to fake this, okay? There's no way. All right, so x is 7. How are we feeling? Great?
Mr.
Awesome?
Mac.
Phenomenal? Cool. Do you guys have snacks at home? You should get some snacks. I gotta zoom out. 3 times a number is 11 more than double the number. Do you want to see it or no?
Hold on.
I'm
How
holding
do I
on.
chat?
Where the heck are you?
Mr.
Kelly, I'm
Mac.
gonna turn you up so I can hear you, okay? Hold on 1 second. Kelly, yes or no?
Yes.
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 Actually, I don't care. It's whatever they say.
It's whatever.
Yes.
Well, this is for you.
They
kid.
say.
Oh God, this is
I
for
will-
you.
Okay, I'm gonna join back in like 20 minutes because
Yeah, sure you will.
I'm gonna look at quiz either 2 or 1.
That's what
And
they
wait till you're
all
on that.
say. That's what they all say. Bye, Lydia Kelly.
You know, at least I'm here. At least I'm here.
Oh, for sure. I mean, like, if you want to be. I hope you're doing this for you and not for me. All right, cool. 3 times a number.
Is 11 more than double?
Yep, so I know 3 times a number and double a number. And I know that these are not equal, not because one is 3x and one is 2x, because x could be 0, right? If x is 0, these would be equal, right? 2 times 0 and 3 times 0 is the same thing. But I know they're not equal because I know 1 is 11 more than the other thing, right? So 3 times a number is 11 more than this one. So this one's bigger. How much bigger is it? 11 bigger than this one. So a lot of people will write a plus 11 here, but now it was already 11 bigger. Now you're adding 11. Now it's 22 bigger. That doesn't make it equal. You need to add 11 to this side. That way, this, which was originally 11 bigger than 2x, is now the same size, right? You could also subtract 11 to this one. That would work too, right? Bring it down by 11. So now that we have a true statement, we can solve for x. Hang on to your butts. I'm going to get my x's together. And I'm going to do that by subtracting. And I'm subtracting 2 x's because that eliminates this. And now my x's are all in one spot. So that goes away and I get 11. 3 x's minus 2 x's, just 1 x's. Oh my God, x is 11. And that makes sense. 3 times 11 is 11 more than 2 times 11, right? 3 11s is 1 more 11 than 2 11s. Okay. So, how do you feel?
Fine.
Good. Joseph,
Yeah.
how do you feel? A scale of 1 to 7.5, how do you feel?
584.
Okay. So we can do better. So if you feel like a solid 6 out of 7.5?
Oh, yeah.
Oh, I knew it. I could tell by looking at you. Did you know we're on the intermediate questions already for quiz 3? That's it. That was the basics. Did you know that if you get all the basics on all the quizzes, then you can very easily get like a B? Very easily.
How's better than an F?
Oh, way better than an F. You don't have an F right now, do you?
No, that's what I get on every single question.
What are you talking? Well, you can't look at the grade percentage because if you understand 60% of this, that means you understand the most important part of everything. Does that make sense?
Yeah.
Right, in normal class, 60% is bad because you only got 60% of them right. And here here's all the possible questions I could ask you. If you understand 60%, that means you understand the heart of the material. That extra 40% is like bonus stuff, essentially. And it factors into your grade that way too, right? You can get a 60 on everything in this class for quizzes, and you can still end up with an A. You really can. Because again, the heart of the material is what you got to understand. It's different than normal. I wish I could change the grade book so it wouldn't look like that, but we don't have a grade book that's built for this.
Negro.
Yeah, I should. The elementary school does exactly what I do, actually, when it comes to how I grade, and they use the same thing. But because grades don't matter as much over there, no one freaks out. But yeah, we got to get a better grade book so it doesn't freak you guys out. All right, anyway, solve each of the following equations. Why is this one intermediate? Because, look, we have x's in two different spots, right? And so all we need to do to make this look like a basic question is get our x's together. In this case, our r's. So if you wanted to, you could subtract 5r to get rid of that, or you could add 4r to get rid of that. I'm going to add 4r. You do you. Okay, there's a nice teal color for Sophie. So this becomes nothing. That's why I did it. So I get 8, and nothing is 8. Don't lose your equal signs. We got 16, and now instead of 5 r's, in order to balance this out, I had to add on 4 r's and get 9 r's over here. So now that this is a basic question, we can just, and all our r's are together, we can just cover this up and say, what plus 16 is 8? Well, it has to be a negative number. Do you see that?
-8.
It's got to be negative 8. So you know what is underneath my finger has to equal negative 8. What number times 9 gets you negative 8? Now, this is a really tough question for you guys a week ago, but now it's super easy because you know fractions are division for lazy people. If I times this number by 9, I get negative 8, don't I? Because the 9's divide out. I don't know. It's how I teach it in pre-algebra, although I don't teach pre-algebra this year. I taught it last year. That's why a lot of my pre-algebra kids are cooking on this stuff. Hey, hooray for fractions. All right, how do you feel? Still good? Okay, because if you understand this concept, guess what? It's more of the same. That's why they're all in the same question. It's testing the same thing. Do you know to handle it when we have y's that are separate or x's that are separate? Sure. I'm going to take away 1.5 y's. You could have subtracted 2.6 to both sides, right? Again, it's y's that I'm taking away. You have to take away the whole term, okay? Can't just take away 1.5 from that. It doesn't work that way. So I get 4 and 1.1 y's, right, when I take away 1.5. And then here is nothing. That's why I did it. And then we get negative 11. 4 plus a negative number clearly is going to get me negative 11. I honestly need this number. Does that make sense? Right? 4 minus 4 is nothing, and then take away 11 gets me negative 11. So I need this number, which is clearly negative 15, right? So 1.1 y's has to equal negative 15. So y is going to equal negative 15 over 1.1. Because when we times that by 1.1, you get negative 15.
Okay, hold on.
Oh, I'm holding on.
Oh, negative 15 over 1.1. Oh. Now you don't understand how. Okay.
Are you okay? Oh, no. Oh, no. Sorry.
I think I understand that.
Yeah? Feeling better?
Yep.
Love it. Okay. Next page. Guess what? It's the same question. It's just more versions of it. Can you get your variables together when they're fractions? Woo! Yes, we can. Because guess what? We know how to get rid of division. We just multiply, right? So I'm going to times everything by 10. You could also times everything by 5. But 10 is better because, or at least, maybe not in this case, but it's better to get in the habit of timesing by a number that gets rid of both at the same time. 10 divided by 10 will get rid of it, right? Because that's 1. 10 divided by 5 will also get rid of it because that's 2. Right? I know. Bunch of horseplay.
What is that?
It's wrestlers. Can't you tell? They're wrestling. All right. 10 divided by 5 is 2. And 2 times 6 is 12. So do you see how that becomes a whole number? Don't lose your equal signs. 10 divided by 10 is 1. 1 times 2t is 2t.
Dang it, I messed up.
10 times 12 is negative 120 because there's a minus sign there. And now this is basically like the first problem we did in this section. I'm going to get my t's together. I like adding if I can. I don't know. I think like adding's easier on my brain. So if I can have the choice of subtracting 2 t's to get rid of this or adding 20 t's to get rid of this, I usually add. But it doesn't matter. There's no like right way to do this. That means 12 is going to equal. What's popping? Go for it. So that's 22 T's. We're live, William, so careful. This is going straight to YouTube. All right. So there we go. Now, if you wanted to, you could stop here and say, what minus 120 is 12? But like, I don't know. You could do that. What minus 120 is 12? Well, it's going to be 120 plus 12 minus 120 gets you 12, right? But also, do you notice how all these are divisible by 2? If you want, you could divide everything by 2 and get this. Might be easier to think about. I don't know. You don't have to. There's no rules here. People teach algebra like it's like these are the steps, but like, good God, is that not how it works? And it sets you up for failure in later math when it's really not like that. It's like, here's a problem. How do you solve it? No one's shown you before. Figure it out. So anyway, what minus 60 is 6? Well, the same concept as before, right? The number that's under here needs to be this. So that way when I take away 60, I get 6, right? So guess what? This is 66. 11t equals 66. And you don't even need to do the little 66 over 11 thing. What times 11 is 66? 6. Which is 66 over 11, right? And I don't know. Whatever floats your boat. You would have got the same answer here. But, you know, the whole point of algebra is to make the problem so easy that you can go like, oh, that makes sense. So you do as much as you need to, and then you know, solve it. How you feeling, Sophie?
Pretty good.
Pretty good? Pretty good. I'll take it. Notice that not all our u's are even together on the same side, so I'm just going to combine these right off the bat. They're like terms, right? They're all u's. Negative 29 u's plus 11 u's is going to be negative 18 u's. Oh, God, they're trying to kick me out. Google, no. It's like Netflix when you've been watching for a long time. They're like, are you still there?
Okay, but why do you have a big old green screen?
I teach online. I've been teaching online since even before the pandemic.
So this is like the whole reason you're doing it?
Yeah, so I used to have like a sheet, but it's really inconvenient to put it away because like I have a house. I need to like live my life. And this is like super easy to deal with. And you can see how I lose a lot of real estate, right? When you can't like see the question underneath here, right? When I have this, right? It works out. And it's kind of fun, right? Thought about wearing a green shirt. I mentioned that earlier because you notice if I have green stuff, it disappears, right? So I could be like a floating head. Green shirt.
You would have more real estate.
That's right. Sometimes I do that for like educational purposes. So this is negative 18u. We still have a minus 6. Now, the more couth amongst you would notice that we have the same number on both sides, and we're taking away 6 from it, and we're adding 13 to it. That's not going to be equal, right? So this is clearly a false statement. However, if you didn't notice right away, you might add 18u to get your u's together, right? And then, if you're paying attention, you'll notice that goes away. That's why I did it. And that goes away as well by coincidence, right? Because negative 18u plus 18u's is nothing. And then we get this. So that indicates either you goofed or there is no solution. In geometry, you'll learn about this symbol, which means contradiction. It's like a little lightning bolt exclamation point. It means that what we started out in the beginning with, we assumed that this was true, right? They told us it was equal, right? It means our assumption was false. That the assumption we made that this equals this must be false. We've proven it to be incorrect. So there's no answer, right? Above, we had t equals 6, right? Because 6 made the equation true. When you plug in 6 to this thing, it becomes equal. But here, there is nothing you could plug in for you to make this equal because it will always be separate, right? At the end of the day, no matter what this number is, you're subtracting 13 from it and adding 6 to the other one, right? It's always going to be separated by 6 on one side and 13 on the other. Oops, sorry. How are you now?
Fine.
Better.
Fine. Better is what I want to hear. Oh no. This one. Can you do it if the numbers are big?
No.
Yeah, you can. It's really not that bad. Because again, I get to be your calculator. And the better thing about me than your calculator is that, one, you don't hit wrong buttons when I'm there, right? Two, if you're adding really big numbers, your calculator's just like, okay, I'll add them. But I might go, why are you doing that? That's not, it literally says divide. Why are you adding, right? Your calculator won't tell you that, which is why I'm better than a calculator. So please utilize me. I'm going to add 23 y's to both sides. Because getting your y's together makes the problem easier to think about, right? So I've got 4 and 10 over here. I'm just going to combine that and make 14. And then that's gone. Are you following me on that? 14? Co. And then we got 7, and clearly it's going to be negative, right? Negative 171 plus 23. Here's what I'm going to do, okay? Here's how I'm going to do this in my head, but I'm writing it on the paper so you can see it. First, I'm going to add 1. That gets me negative 170. Then I'm going to add 20. That gets me negative 150. And then I'm going to add 2 more. See how I added 23 in total? That means negative 148y. This is literally how I think in my head. Instead of adding 23, that's a hard problem, right? I will add 1 to get to 170, add 20 to get to 150, and add 2 to get to 148.
Why can't you just pretend 120 is just like a positive and then subtract 23?
And then make it negative?
Yeah.
That's fine. Whatever you want to do. 171 minus 23 is kind of tough too, because you kind of have to borrow in your head. If I was subtracting 23, I'd subtract 20 first and get 151. Subtract 1 for 1 after that, get 150, and then subtract 2. Sound familiar?
Hold on.
But that's just how I do it in my head.
Okay.
Welcome to my ASMR channel. ASMR. All right, so here we go. 7 minus what is 14?
7. Oh wait.
7 minus 7 is 0. Ah, you want it to be plus 7, don't you? So what if we did 7 minus negative 7? That's plus 7, right?
Yo.
So we know what's underneath here has to be negative 7. So 148y has to equal negative 7. So I know y is going to equal negative 7 over 148. Because when you times that by 148, you do get negative 7, don't you? Ta-da. Ta-da! That actually comes out, you can simplify that to 1 over 20. No, you can't. Oh, I was hoping that'd be a 47. It's a 48. Darn.
But wouldn't the 148 have to be on top to simplify it?
Well, it would be 1 over, like, imagine I had 7 over 147. That's 7 times 1, and that's 7 times 20 gets me 140, so 21 gets me 147. Those 7s divide out. Right? If I had it flipped, it'd be the exact same thing, except it'd be 21 over 1, 21, right? But yeah, does that make sense? Okay, cool. Go away. Turn the page. What? Solve the equation. 6x minus 7 equals x over 7. I don't write my fractions like that, but the book does, so I left it the same. X over 7 plus 19, and found that x equals 3. He then shakes his head, and he starts over. Drama.
I thought it was the book dividing.
What?
I thought it was the book dividing.
It is. Division is the same thing as fractions. It's okay. It's okay. It's okay. But now you know, right? You never thought about it that way, and it makes it so much easier.
Just looking at the book, I assumed that was.
Yeah, it's the exact same thing. A lot of you guys are struggling with that. That's why I mentioned it.
All my equations, I did.
Yep.
In the book,
And that's why I mentioned it. Mm-hmm.
That wasn't funny until he goes, oh.
I know what I'm inside your brains. I know pretty well what you guys think and how you think. 3 I know it is. 3 over 7 is a fraction, right? And that's clearly not going to be a fraction, right? It's going to be like 18 minus 7. So how will a fraction ever equal a whole number? It can't. So he knows immediately that can't be the right answer, right? It's not going to work without even doing the math. That's 19 and 3/7. That's 11, right? Fractions
Yay.
do not equal whole numbers, you idiot.
Oh.
Got him.
How am I gonna memorize all this?
You don't need to memorize it.
No.
Guess what I'm going to do after I'm done with this, Sophie?
That's what you mean by do not was the equal.
Yeah. Mm-hmm. Well, No, I mean like when you're writing your problems out, don't forget to write your equal sign that's in between these.
No,
Right.
I'm talking about like when you do the equal with the line through, that's what you mean.
Does not equal. Yep. That's an official symbol. That's not just me making it up. Yep. More you know.
Okay, well, hold on.
I'm holding on. So, yeah, you know what I'm going to do when I'm done with this lecture and then we move on to a different quiz? I'm literally going to give this to Joseph.
Oh.
Now, the problem is I'm giving it to Joseph. If you wanted to, I can make a copy of it and give it to you, too.
No, because I'm doing the same exact thing. Right?
But why would you do... See, this is
Because
what...
I'm taking notes.
Yeah, but what's the point of taking notes if you can get... Right? What's the point of taking notes if you can just learn and then have the notes for free later? I used to do that. I used to do handmade color...
When I write down things of the right thing, that's how it makes me remember.
Maybe. Practice makes permanent, but if you don't understand what it means, it doesn't do any good, right? Which is why I say focus on the learning rather than the note-taking. Can you do both? Sure, but it takes a lot of time and it takes a lot of focus. And it's hard to do for a lot of people, including me. But I used to literally make handmade notes for my students, like in color, pre-made with Sharpies. I can show them to you guys sometime. And it was because I'd be like, don't write the notes. My notes are better than yours. They're in color. They're perfectly matched up with what I'm saying. Just watch the show. The only problem with doing the show is that it doesn't work when you do it every single day. It doesn't. It just doesn't. It just doesn't. Regular teachers lecture every day. We've seen how that works for you guys. It really doesn't, right? Same thing in math. That's why we have to get you up at the boards, and it's super annoying, and it makes a lot of extra work for me, but it works better. It just does. My brother is 3 times as old as I am. Okay, so let's have X be my age. And let's have your brother's age be, how is my brother's age related to my age? Because we call it Y. But if we can talk about it in terms of X, right? If I'm X and my brother's 3 times as old as me, how can we represent his age with X? Well, plus 3 is a good guess, except that means he's 3 years older than me, right? Like if I'm 10, he'd be 13, right? That's not what they're saying. 3 times older than me. So if I'm 10, he's like 30, right? So it's not X plus 3. It's 3 times X or 3X. And I'm glad we're having this conversation because for some of us in this class, and I think you a little bit, get confused about what this means. It just means 3 times X. That's it. Right? There's no dot there. There's no X to mean times. Right? That just means 3 times X. 3 X's. Right? Cool?
Can you move your...
I can, yeah. Sorry. This is dangerous. Let's do this. And then, do you see how I have like a window here? I can fix that by moving this over and hopefully I don't slice my finger open on the sheet metal that's inside here. There we go. That might help. Yes, kind of a weird angle on my face, but that's okay. Yeah, look at that. Okay, cool. So that's my brother's age, but that's not what they want to know. 3 years from now, he'll be twice as old as I will be. How old is my brother? So 3 years from now, I will be X plus 3. That's kind of what we talked about earlier when Joseph was thinking, right? X plus 3 is how old I am 3 years from now. If I'm X now, I'm that plus 3 years from now. My age 3 years from now. Good talk. 3 years from now, my brother's also going to be older, right? He's no longer going to be this old. He's going to be this old plus 3, right? However much that is plus 3. Same thing, my brother. Okay, awesome. That's my brother's age 3 years from now. How old is he currently is what we want to find out. Well, I know there's a relationship here because right now I don't really have any equal signs relating any of these, right? I mean, I have equal signs telling you what they mean. But notice, he will be twice as old as I will be 3 years from now. So we're talking about this time period, right? 3 years from now. These are related. How are they related? It's not that I will be the same age as him 3 years from now. That wouldn't make any sense. If he's older than me now, he'll be older than me later, right? But it is saying he will be twice as old as I will be. Meaning that whatever this number is, think of that as a single number, right? That's 2 times this. So right now they're not equal. This is twice as big as that. Now they're equal, right? Twice what I am will be the same as him. Again, be careful. A lot of people think, ooh, twice as old as I will be, double that, right? Turn your brain on. That would make it 4 times older than you. Not equal. So now that we have an equal statement, let's solve. I distributed that too. You follow me on that one? If I subtract my x's to make this problem easier to think about, I'm going to subtract 2 x's from both sides so that I get 6 equals 1x plus 3. And now it's so easy to think about, the answer's obvious. What number plus 3 is 6? 3. So I am currently 3. How old is my brother currently? Well, if I'm currently 3, this means 3 times, right? So he's 9. Brother is 9. I am 3. So he is 3 times older than me now. Later, he'll be twice as old as me. If I'm 3 now, I'm 6 later. If he's 9 now, he's 12 later. 6 and 12 is double, right? Twice. Cool. Sophie!
What?
How do you feel? Pretty good.
I'm looking at something.
She's looking at something. Taking a gander.
Okay, for the next problem, what I've always done is I know it's probably not the right way to do it.
Okay.
I've always done it where, okay, I have to go through it real quick to explain how I've done it.
Yeah, no worries.
So I would basically do what everything said, but do the opposite of what it says in reverse order, going from the bottom of the paragraph up.
Whoa. Okay, let's explore this. This is going to be fun. All right, so what do you mean?
So, wait, the ending on this one's hard to try to do it, but I can't.
No, don't worry about it. I don't want to put you on the spot. That's interesting. Cause that,
I don't think that. Oh, so you add 4 times the number of paces.
okay.
So I would do 4.
Four.
Then I would do 15 plus 9. And then I would divide by 2.
Instead of, why are you dividing by 2?
I mean multiply by 2. That's what I would have done.
Why are you timesing by 2?
Because it said divide by 2. And I figured to try to do it.
Oh, I see what you're saying. I think you're onto something. I think what you're going to end up doing, though, is you're making little mistakes on the way. But that's not a bad way of thinking about it.
I wasn't sure how to do it, so I just
Sure.
kind of guessed the
Sure.
way, hoping it would work out eventually.
Well, let's go down the line, because I think most people are going to do it that way. But I think what you're saying is valid.
I do have one question.
Yeah, what's up?
Okay, so you could have done it like 2 ways. I probably would have accidentally made the mistake. So when you do 3 minus 2, like x, you just get x. But like, can it also be considered as 1x?
Yes, 1x is the same thing as x.
Yeah.
Yes, 1 times x is the same thing as x, yeah.
Alright, right. You can't add x to a number because I was thinking like it could be mistaken as adding the 1 plus the 3.
Yeah. And the reason you can't add these is because that's 3 1s and that's 1 x's.
Yeah.
If x were 1, then we have 1 1 and 3 1s. We can add that, 4 1s, but we don't know what x is, so yep. Have to combine like terms. Glad you brought that up. All right, this one. Think of a number that is 17 more. Okay, 17 more than what? 17 more is what I write there, right? Imagine a number, and we're adding 17 to it. That's 17 more than the number you imagined, right? And we're 17 more than 6 times the number of paces, okay? We'll have x be the number of paces, divided by 2. So it's 17 more than this.
So that'd be 3x plus 17.
It will be. We can simplify that, right? This is equal to the sum, so we're adding apparently, when 12 more than something. Okay, 12 more than 9 minus 15. This number is added to 4 times the number of paces. You can put that in parentheses to be like, hey, whatever this number is, add 4x to it, and then I want 12 more than it. But honestly, it doesn't matter. It's all addition and subtraction, right? But you do you. Joseph's right. That's just 3 x's. And 9 minus 15 is going to be a negative 6. Again, get that negative sign out of the way first. A lot of you guys are missing negatives. Clearly, that's a negative answer. Write a minus sign. 9 and 15, 6. Plus 4x plus 12. Oh, and look. Negative 6 and 12 we combine to just positive 6. Right? 12 minus 6 is just 6. Or negative 6 plus 12, same thing, 6.
Hold on.
Oh, I'm holding on. All right, where does it hurt? Here?
Okay, so you do 12 plus 6.
Yeah. I'm just combining like terms, right? Trying to clean it up. The less terms there are, the easier it is for my brain to think about it. And speaking of which, let's combine these x terms. That way I don't have something times 3 plus 17 equals something times 4 plus 16. That's too complex for my brain. I'm going to subtract 3x's from both sides. You could subtract 4x's. It doesn't matter. I just want to get rid of this one.
But when it's right, it'd be easier because it would make it a 0.
Yeah, and that's a positive, right? If you subtracted 4x's, this would be 0, and that would be a negative x, right? It's nicer when things are positive, so I try to keep it that way. So that's nothing in 17, and that's a single x, or 1x if you want. And now the problems like went from, I don't know, to, oh, this is so easy. Of course the answer is 11. Because 10 plus 6 is 16, so 11 plus 6 has to be 17.
Oh no.
Oh, no.
I tried circling it. It's not.
I'm sorry for your loss. Oh, no. Benedetto. Come back, Benedetto. Don't you die on me. Page 8. Did you know we're almost done with the intermediate? Oh my God, insane, right? Leah has a bag full of nickels and dimes. If there are twice as many dimes as nickels, she has 28.50 in her bag. How many nickels does she have in her bag? All right, we're doing some detective work here. She's got nickels and dimes. I don't know how many nickels or dimes we have, so that seems like good variables, but I do know the relationship. The number of nickels is not equal to the number of dimes, right? She doesn't have 10 nickels and 10 dimes, or 20 nickels and 20 dimes, right? She has twice as many dimes as nickels. So there are more dimes than there are nickels. So this is not a true statement. However, if we were to divide the number of dimes in half, we'd have the same number, right? Or if we were to times the nickels by 2, we'd have the same amount, right? I like timesing more than dividing. So if we double the amount of nickels, we get the same amount of dimes, right? Because she has twice as many dimes than she has nickels. So
it's not broken down into thirds.
why thirds? Ooh, I get what you're saying.
So is it not though?
So like 1 part dimes, 2 parts dimes, 1 part nickels. Is that what you're thinking about? That's clever.
You could just do 2.50 divided by 3 times 2 for dimes, but then that wouldn't be anything for nickel.
I get what you're saying, right? Assuming... No, you're right. That would totally work, right? 1/3 of the money is going to be nickels. No, 2/3 of the money is going to be nickels, and 1/3 of the money is going to be dimes.
So 2/3 would be nickels?
Right, because there's... No.
But if there's more dimes than nickels.
Yeah. 2/3 is going to be dimes, 1/3 is going to be nickels.
So that would work though?
Yes, it actually would work. That's clever. That's an interesting way to think about it. That is an interesting way of thinking about it.
The 50 would divide even.
Yeah, I like that. That's nice. That's clever. I like that. All right. That's actually going to come in handy later on. Not here, but like later on in the year. That is some clever thinking. Well done, Joseph. So the way I think about it is I think, and I'm trying to keep it consistent with what we've kind of learned. If I know the number of dimes, I can just, If I know the number of nickels, let's start there, because my brain is stuck one way. And I times that by 5 cents, that's how much money's coming from the nickels, right? Does that make sense? Right, if I have 20 nickels, then I have $1, because each one's worth 5 cents. So this is telling me how much money I'm getting from the nickels. If I add that to the amount of money I'm getting from the dimes, right, 10 cents for every dime, it should add up to the total amount of money. So again, D plus N is not 28.50. D stands for the number of coins, right? And you don't just add up the coins, and that's how, unless they're pennies, right? That's how much money you have. So this would not be solvable because there are lots of ways I could make 28.50 with dimes and nickels, right? I could have 10 nickels to get 50 cents, and the rest could be dimes or something, right? But I know this relationship. The dimes have to be equal to double the nickels. So instead of thinking of this as dimes, if I told you dimes was 12, could you plug in 12 for D? Sure, right? D equals 12, right? Plug in 12, right? Well, I'm telling you from earlier that D is 2n. So I'm going to plug in 2n for D. So here's D. I'm going to plug in 2n. Whenever we plug something in, you always wrap it in parentheses just in case. Sometimes it does matter. And now I can combine my n's, right? How many n's do I have here? It looks like I've got 0.05 n's plus 0.2 n's, right? 2 times 0.10. And don't lose those decimals. And that's going to be 2850. So in total, I have 0.25 n's. Now, like many of you, I do not enjoy decimals. But maybe you would in this case, right? Maybe you'd think, how many quarters go into 2850, right? I don't know. 2 quarters go into 50 cents. 4 quarters go into $1, right? So 4 times 28 plus 2. I don't know. I'm going to do times 100 and just get rid of decimals here. And why am I choosing to times by 100? Because timesing by 10 moves the decimal place over 1, right?
So I'm gonna open 2 places.
Yep. It's really the same problem. I mean, I don't know.
Is it just, even though in reality you don't have that many times a nickel, it's just the same thing but it's elevated?
Yeah, because we're changing it by the same amount on both sides, it's going to give us the same answer. It's just a different way of looking at it. It's like we're not taking the stickers off the Rubik's Cube, we're just moving it, right? Which is the same cube, it's just a different way of looking at it. So now we're here. So the question is, what number do you times by 25 to get this? Well, this is the number you times by 25 to get that, and I'll accept that. But people are probably asking, like, how many nickels do you have? And if you tell them 2,850 over 25 nickels, they'll probably go, what does that mean? So how many times does 25 go into this? Let's think. How many times does 25 go into 50? Bueller. 25 goes into 50. How many times? Twice, right? So let's write that down. 800. Now that's a tough question. How many times does 25 go into 100? 4 times. So if it goes into 100 4 times, it goes into 200 8 times, right? We're going to have to do 4 quarters 8 times. So that's 4 times 8, 32. 32 times 25 is 800. Because 25 times 4 gets us $1 or 100. And if we do 8 times that, we get 800, right? So 32. How many times does 25 go into 2,000? Easier question. How many times does 25 go into 1,000? Easier question. How many times does 25 go into 100? 4 times. So it goes into 1,000 40 times, which means it goes into 2,000 80 times. Yeah, do you see what I'm doing there? Right? I'm kind of doing like distribution, right? Instead of dividing 2,850 by 25, I'm dividing 2,000 by 25, I'm dividing 800 by 25, and I'm dividing 50 by 25. Makes it easier in my brain, because I couldn't do that in my head without breaking it down. And again, I use what I know to figure out what I don't. This is not a trick I'm teaching you. This is literally how people do math in the real world. So, Faith!
Yes.
How are you now?
Pretty good.
Pretty good. Are you sure?
Yeah.
Sophie, this is supposed to be hard. These are intermediate questions.
I'm tired.
I know. Is that your Mountain Dew?
Yeah.
Have you consumed it yet? You should.
I know. Gatorade's healthier, so I'm working on that first.
That's my combo. Gatorade and Mountain Dew all day. Stay hydrated and then keep myself awake.
What do you mean Gatorade?
And Doritos.
They sounded good, but they're not.
Sorry. Abby was asked by her teacher to subtract 4 from a certain number. This one's actually not that bad. Right? Take 4 from some number, right? You follow me?
Yeah.
Then divide that result by 12. Hooray for giant division bars. Whatever that is, divide it by 12. No parentheses needed. Just take that and divide it by 12. Instead, what did she do? Ah, silly goose. She subtracted 12 and then divided it by 4. And she got an answer of -1. Now, she should have done this. Now, they didn't tell us what this mystery number was, right? Obviously, she knew it because she did it to get -1, right? So if we can figure out what that mystery number is from what she did do, we can figure out what the mystery number should be for what she should do, and then figure out what she should have gotten.
Wouldn't you do 12, not 1 plus 12? The negative 1 plus negative 12.
Are you trying to add this and that together?
Yeah.
No, because this all is in division. So remember, if we think about this, this is really a quarter of x, and this is negative 3. Right? So if you wanted to add them, you'd have to figure out like individual terms. Right now, it's all one term, so we can't add it into individual parts. Good thought, though. So what I'm going to do is I'm going to get rid of this giant divided by 4, because 1, it's division, and 2, it prevents me from like combining things, right, like we talked about. So I'm going to times this by 4 and times that by 4. And the reason I chose 4 was because 4 divided by 4 is 1. And 1 times anything is itself. And then 4 times negative 1 is negative 4. So it's the same thing. This is literally the same question as this. It's just this is way easier to think about. So what number do I take 12 from to get negative 4? Well, clearly that number has to be less than 12, right? Because otherwise I'll end up with a positive answer. So the way I think about it is I need 12 minus 12 to get 0. Take away 4 more, I get negative 4. So what number is this? 8. So x has to be 8. So 8 minus 12 is negative 4. Cool, but that's not what they wanted. They wanted to know what answer should she have gotten with this mystery number, right? She should have done 8 minus 4. Well, that's 4. And got 4 over 12. Otherwise known as 1/3. I'll take either. Remember, 4 over 12 is 1/3, because I can factor out a 4 from the top, and I can factor out a 4 from the bottom. All division and multiplication, division divides out, 1/3. Hooray for dividing out. That's why we spent so much time on it early on. Turns out it's super useful, right? Dividing out, dividing out. Hooray. Sophie,
What?
how you feeling?
So I don't get what the answer is. Is it 1/3 or 4?
They're both the same thing, because 4/12 I can write like this. Isn't that 4/12?
Yeah.
And see how the 4's divide out?
Yeah.
It's just a simplified version. We call it simpler because you can't factor anything else out of it.
So the one on the left is the right way to do it, and then the one
On the right is bonus points. Normal math teachers would mark this half off because, oh, it's not in simplest form. I don't care. I literally don't care.
I'm talking about like the different things. So like.
Wah? Oh, yeah. This is what she did on accident, and we found out that x was 8, and she should have taken that same number, 8, and actually done this with it. Does that make sense?
So that side's wrong on what she did.
Yeah, what she shouldn't have done, here's what she should have done. So we found out that what she did do, she must have done it with 8. So we're going to do the right thing this time with 8. And we did. What's the answer? She should have gotten 1/3. The way she did it, you get her a nicer answer, but it wasn't what the teacher asked her to do. And we all know we're supposed to listen to our teachers and obey whatever they say. All right. Did you know we're almost done with the intermediate, like for realsies?
Oh, yeah. 2 questions.
I know. And then we can take a break. So, how do you solve problem Maria? Guess what? The problem is, this is hard to think about. Why is it hard to think about? Because there's lots of fractions. So what if we got rid of them? Remember, when you multiply, you have to do it to every single term. Otherwise, it doesn't keep things balanced, right? So imagine this. If I had 2 plus 5 equals 7. True statement, right? If I were to times, I don't know, the 2 by 3 and the 7 by 3, but not the 5, I get 6 plus 5 equals 21. Do you see how it's no longer true? But what if I do multiply every term? Oh, yeah. It is true, right? So the lesson to be learned from here is that we have to multiply every term, or divide every term if we're going to do that, right? So I'm going to multiply each one of these terms by a certain number. I'm going to multiply everything by 5. And why? Because that's going to get rid of my divides by 5s on the bottom. When I do that, I get 20 over x, right, times by the top, divide by the bottom. I get 5 divided by 5, which is 1. That's why I did it. So you should divide first, right? I mean, you can do whatever you want, but I'm going to divide first. 5 divided by 5 is 1. 1 times a negative 6 is negative 6. Hooray! Times by the top, divide by x. Equal sign. Don't lose your equal signs when you're rewriting this stuff. Super easy to do. And turn that into a plus sign, then you're like, oh God, what happened? Right? 5 divided by 5 is 1. 1 times 2 is 2. So it's already easier to look at. However, what if we got rid of this fraction? You know how I can times everything by 5 to get rid of things? X is just a number. So why don't I just times by x to everything? So now, over here, I'll start over here. 2x is what I get from 2 times x. X divided by x. What's anything divided by itself? Anything divided by itself is 1. So I get 1 times 10, which is 10. That's why I did it. Negative 6 times x is negative 6x. X divided by x is 1. 1 times 20 is 20. And now this is really actually not that bad to look at. Now you might notice before we go on that all of these are divisible by 2. So if you wanted to, you could divide them all by 2. Remember, you have to do it every term. Or you could just not and keep going. I don't care. I'm going to do 20 and 10 and add those together and get 30. And then negative 6x equals 2x. You could do negative 6x plus 30x or 30 minus 6x. It doesn't matter, right? Just keep the signs together. Let's get our x's together. Looks like we've got 30 equals 8x. So x is the number that you times by 8 to get 30. If I times this by 8, 8's divide out, and I get 30. Did I do it right? This simplifies to 15 over 4. Yeah, that looks right. Okay. Whatever. How you feeling? About ready for a break?
Mm-hmm.
Mm-hmm.
Have they come back yet?
No. They're not coming back. You know this. If you're watching the video later, and I know you're not Lydia, I know you're not coming back. It's okay. No shame. I don't blame you. Here's my advice here. Let a equal the root of 2r. Now that's really what we're doing. Whenever we like cover up something with a thumb and we say, what divided by 4 is 28? I'm basically saying replace that with a. This big weird thing. Replace it with something. A, right? So that's what I'm doing here. 50 minus something equals something plus 42. Right? Now we have two somethings there, which makes it kind of confusing to think about. So I'm going to rewrite it as this. Minus something equals something plus 42. And now we just solve for a. And once we have a, we can then solve for r. So I'm going to get my a's together. That's nothing now, which is why I did it. What's up?
Nothing.
What? Nice shoes.
Oh yeah.
Oh, yeah. Way to respond to a compliment. Oh, yeah. I know. That's confidence. I like that. Now you might notice everything's divisible by 2. You don't have to do this. You can just do what plus 42 is 50? 8. So a equals 4. Or you can divide everything by 2 and you could be like, what plus 21 equals 25? 4, right? I don't know. The whole point of doing algebra is to do it so it's so easy for you. Now the problem is that we don't want to find a. We want to find r. But we know how a and r are related.
Hold on.
A is 4. I'm holding on.
How did 8 get there?
What number plus 42 is 50?
Oh.
Yeah, good question. You have to ask those questions. Those are the dumb questions, but you have to ask them. If you don't, your entire learning is held back by something this tiny. And that's stupid to not ask that question. It's stupid to not ask stupid questions.
4 equals.
So if a is 4, then we know 4 equals root of 2r. Remember, the root means what number times itself gets you the number inside. So 4 times itself must get us the number inside. What number do you root and get 4? The root of what is 4? 16, yeah. Right, because 4 times 4 is 16. So the root of 16 is 4. So if we know that the root of 16 is 4, we know whatever's inside here is 16. 2r is 16. What is r? If 2r is 16, 8. Because 2 times 8 is 16. And that checks out. If r is 8, we get root of 16, which we know is 4. 50 minus 4 is 46. Again, we'll get 4 over here, because 16 rooted is 4. 4 plus 42 is 46. Yep, works out. It balances our equation. Did you know that we're done with the intermediate questions on quiz 3? Let's take a break. Now, we do only have until 6 because the other class is going to come in here. But in theory, we could continue what you're doing when they show up because they're going to want to see it anyway. And then we could just do like quiz 3 or whatever they want to see first after you guys leave. So, I don't know. And maybe they don't even show up. Who knows? Who's to say?
There was a couple of them that were gonna. I don't know if they are.
I figured if I had a class that really attended, it would be, what is it, 3rd hour? Yeah, 3rd hour.
I have a quick question for you.
Hello.
On page, about on page 2.
Page 2? Yeah, what's up?
On page 2. Yeah. You said you would accept r equals negative 1.2 over 4.
Yeah, I love that.
I just wanted to. I thought you said you would accept that earlier today.
That is the number when you times it by 4, it gets you negative 1.2. If you want to simplify that, that's negative 0.3.
Wait,
If you want to simplify,
can you promise not to get mad? Tennessee, can you go for D real quick?
I'm not going to get mad. Why would I get mad? Who hurt you, Joseph? Past math teachers? Math trauma. Not
You got
okay.
yelled at in 4th grade.
Yeah.
Oh my God, you know an exact moment? You're like, oh,
Yeah.
I know.
Yes, he
4th
had
grade.
to change classes because he got yelled
By
at so
himself.
bad.
What?
Yes, because she didn't know how to work the projector, so he tried telling her how, and she flipped
No,
out on him.
that's not what happened. She said, do your home. She said, if you were on the board, do your homework, then do this. And then apparently he told the class, do this first, then do your homework. And I didn't hear her say that because I was busy doing my homework. And she yelled at me. I was doing my math homework, but she wanted me to
Oh my God.
get done without wait.
Yes, and he had to go to a different class for her.
What?
Because she was yelling at me there, like,
Wow.
it was a sub. Yeah, she was suspended for teaching for a year.
Whoa.
She still subs, I think, a little.
All right. Well, we speak no evil unless it's about me, but I'm sorry you endured this trauma. 9 divided by 9 is why I set that up, right? So that divides out, and I get negative 6s. In order to get away with that, I have to times the other side. And by other side, I mean all of the terms. There's only 2 terms, right? I get negative 18. So s is going to be positive 3, because a positive times a negative is a negative. And 3 times 6 is 18. That's all. Do you want to go on the advanced questions when we're done, or do you want us to go to a different quiz?
Yes.
Advanced questions?
Yes.
Are we trying to like 100% quiz 3? What are we doing here? But you know, like quiz 1 is like half your grade, and quiz 2 and quiz 3 combined is the other half.
I think probably 2 or 1.
I don't know.
Because isn't aren't the advanced questions what's like?
Yeah. So after you go from like no check marks in a row, and you get on the board, you've gotten 60% of the points out of that category, right? And if you jump into intermediate, great, you just increase 20% more. But like the first jump is a 60% increase. The other's just a 20%. And then after that, it's another 20% to make 100, right? So the basics, the heart of the material is the most important part, which is why when you're like, I got a 60 on something. Yes, you understand the heart of the material. 60% of the material, the vast majority, you know without having to blink how it works. The last 40% is all fluff, right? It's good stuff. It's juicy. It's fun. But it's not essential, which is why I structure my grade book so that if you get a 60 on everything, quiz-wise, you can still come out of here with like a B, right? You don't need to understand advanced stuff. Or even intermediate to get a B. Intermediate is kind of what separates the B from the A, I suppose. But again, screw grades. I've talked about grades. I talk about grades more every year, and I literally think grades should be abolished. I hate having to talk about it. I hate it. I hate it. Anyway, focuses on the wrong thing. It stresses you guys out. Not fun. Find A if x equals 5 is a solution to this equation. So if x is 5, that means division, right? What must A be? 5 divided by what is 6? Remember, it's not something divided by 5. This is not 30. A is not 30, right? So how do you solve a problem like Maria? Well, five. What times 6 is 5? When you times that by 6, you get 5. Why is this advanced? Why does this have a diamond? I don't know. I don't know. Words are hard. I don't know. That's it.
So that's the answer.
Yeah. Isn't that the number when you times by 6 gets 5? Isn't that the number I need because of this? A has to be 5/6. 5 divided by 5/6 is 6, it turns out. Fun little property there. Okay. Solve these equations. Now, why are these advanced and not intermediate? Intermediate has 2 r's, right? Multiple r's in different spots. But these are also kind of locked in, kind of like that division problem, right? Where you wanted to add the 1 to it, right? You couldn't because it was locked into division, right? It was all one term. This is all one giant term. And so we have to divide this up. And by divide it up, I mean expand it out. And by expand it, I mean let's distribute. So then we can see individually what the pieces are. Remember, distribution is multiplication. And now we can just start putting our terms together, right? Before we couldn't. Now, why does this work? Let me tell you why. 5 times 3 minus r. If I told you 5 times 7, doesn't that mean 7 plus 7 plus, 7 plus 7 plus 7 plus 7 plus 7, right? If I tell you 5 times 3 minus r, that means take 3 minus r and add it to itself 5 times. And there's a shortcut for this. But that's what it means. Looks like I have 15 with my 3's, and I have negative 5 r's. See the shortcut? That's why it works. That's why distribution works. You can either times the whole thing by 5, or you can times the individual pieces by 5. It'll be the same thing, right? Imagine if I had a box of 10 pens. I could times that by 5 and get 5 boxes, right? Or I could times the individual pieces by 5 and get 50 pens. It's the same amount, right? So we can do the whole thing times 5, this, or we can do the individual pieces. In this case, we want individual pieces so we can combine them. Time to get our r's together. Use r a lot in this one. So it looks like we're going to have a positive 3r over here minus 14 equals 15 plus nothing, which is why I did it, right? So now it's easier to think about. What minus 14 is 15? Well, I need this one, because when I take away 14, I get 15, right? What is that? Take away 14, I get 15. So what is this number?
29.
29. So whatever's underneath my finger is 29. What times 3 is 29? That times 3 is 29. It's almost 10, right? 30 divided by 3 would be 10. But it's 9 2/3 or 29 thirds. Hooray for improper fractions. How you feeling?
Good enough.
Okay.
Because I already know I'm not going to be able to get to that far on the...
Then why are we doing this?
That's why I just figured that out. I don't know.
Okay, so we distribute,
Change
right?
to 1.
And then we add to get our r's together. And then I just used logic. 29 minus 14 is 15. Right? This minus 14 is 15. What is that? 29. 29 over 3 times 3 gets you 29 when you times it by 3. Don't want to see this one?
No.
You're not even curious?
No.
Not even a little?
Probably not.
Yeah.
So do I. I'm not going to copy down notes this time because you're going to do it. I know because I already started.
Quiz 1. Let's see if I have a copy of it. Well, I mean, sure, if you didn't write anything on it, I guess. I'm not using it.
Besides the folder at the front.
Oh, that's not you. That's the other class. Where's your quiz 1? Here's your quiz 2. Is your quiz 1 in here? It is. You don't need this.
Nope.
In fact, I will go to the copier and copy this after I'm done. Right? Don't let me forget. And you both can have it. Hooray.
I want the original.
You want the OG? Okay. Should we start with the beginning here?
Can you do number 2B?
2B. So this one down here? Oh, for sure.
That one.
It always does. Every single time. You can rearrange this as much as you want as long as you keep the signs together. I'm going to color code this, okay? Do you see how the 102 is positive? Do you see how... I'm using a different color. Do you see how the 198 is negative? Do you see how the 109 is negative? Do you see how the 2000 is positive?
Yes.
Okay. Any order you want to do them in. I would prefer 2000 minus 1998. And I can do that. Because 2000 minus 1998 is the same thing as negative 1998 plus 2000. So I'm going to rewrite that. 2000. And it's still positive. I didn't change anything. I'm not changing the problem. Minus 1998. Again, didn't change anything. See how it's still negative? Well, let's do that. This is clearly 2. All right, the other one I might want to work with, and again, you could add 102 onto this now and get 104, but I noticed that 102 and 109 are pretty close together. So what I'm going to do is I'm going to do, I don't know, it doesn't really matter how you do it. I'm going to do negative 109 plus 102. Again, why plus? Because 102 is positive. You could also do 102 minus 109. Same thing, doesn't matter. And this will become negative 7. Don't you agree? Negative 7 plus 2 or 2 minus 7. Doesn't matter. I'll do 2 minus 7, negative 5. Right? And that's the key. It should make sense. Over here, 87 minus 83, 4. 4 minus 19 is a negative answer. Negative 15. That's it. And just for those playing along at home, that's a term, that's a term. We do not combine the 8 and the 2 and get 10 and times by 4 to get 40. No, 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 no. That's what this is. Right? It says 8 plus 2 times 4. So that's 10 times 4, which is 40. This is 8 plus 8, which is 16. For the love of God, start using terms. I got sick, and Mr. Cole took over to do like PEMDAS and stuff with you guys, which is unfortunate because I try to avoid PEMDAS as much as possible because if you think about terms, you don't need PEMDAS. And good news, PEMDAS doesn't cover everything, so even memorizing that, while it's helpful now, won't be helpful later.
That was like maybe probably like 4th to 6th, 7th, 8th grade.
And I get why they do it, because it works. If you just follow the steps, you get the right answer. But, like, there's got to be more to life, man. And here's the problem. As soon as we have something that doesn't work that way, then it's like, great, throw out the whole book. We have to teach you a whole new thing. Like, it gets you the right answer on the test, so that's why we teach it. And it's like, God, that isn't a good goal. All right, anyway. Here, words are really hard. Do you want me to do it or no? You know you don't have to do the ones that have check marks, right? So you're going to look at your check sheet? Good, good. Because, like, some of you guys are still figuring that one out. Where I'll grade something and be like, oh, this is great. And then I'll realize, because they already know it. Do the ones you don't know yet. Learn those. And it's like, no, I'm going to sit here and continue to do the same questions I've always done.
You gave me back quiz.
I gave you back all of them. Every single one.
And then I gave it back to you today.
I gave it back to you.
Oh, that's right. I need to scan them. I will get yours out. You need to give it back to me. I need to put them in the grade book.
That's how the only way we can figure out what we need.
Yep, for sure. For sure, Z.
I know what I have to do.
I'm going to put these in my locker real quick.
Good idea.
I need to bring my book back.
Okay. You do that. Don't mix this up. Look in there, find your stuff.
So shuffle them all together.
Yeah, you're funny. I like you. Don't do that. I will cry. They're already pretty shuffled because again they're like all divided by person rather than like quiz 3, quiz 2, quiz 1.
Well, both of ours should all be at the back.
If you gave them to me first as your exiting door, yes.
Oh, never mind then.
Yeah, I don't have them in alphabetical. I didn't have time.
What? I just need this. Well, the number 1 check sheet, it's hard to.
Ba, 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 bum. Ba, 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 bum. Ba, ba, bum. Ba, 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 bum. Ba, ba, bum. Ba, 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 bum. Ba, 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 bum. Oh, I do have something great. Nice. I'm getting parched.
I got too much stuff.
Too much. And then I get done at 9 tonight, and then I have to write all your new quiz versions. Every single one of them.
You're getting no sleep.
6 different ones. I was here until 2:30 last night.
Why?
I had to get these graded so I could get them back to you. I almost got them all done. I just couldn't get them scanned. Copier's being weird.
How are you still alive?
Well, I had to do it because you have to have feedback, right? Which is funny because student late assignment, it's like, oh, sorry, no big deal, right? But me, I get that back to you a day late, and it's like, oh my God, Mr. Mac!
It's a day late. You're supposed to do the paper the second I give it back.
That's all I have with Mr. Leonard, but that's okay.
Yeah, don't be mean to your teachers,
He
okay?
says he makes comments whenever you say that.
They do not get paid. Teachers do not get paid for all this extra work they do. If we only did the work we got paid for, you would never get anything graded ever. Because there's no time during the day to grade. Like, when would we do it?
Whenever my mom had to go to school or home, my dad was like, they should be paying you.
Yes, absolutely. Now, do I do free labor anyway? Absolutely I do, because I love you guys and you have to. That's just the name of the game.
That's my mom.
But yes, every time you think about that, it should be yes. Teachers do not get paid enough just by the fact that we do free labor, right? No other job has to do stuff like this.
You would figure.
Anyway, that's just how things are. Someday we'll change society, I hope. But until then, teachers like me and my mom, oh my God, my mom, will continue giving free labor away because we care about you guys and go home to houses that are too small with not enough money to turn the heat on. All right, so hello. Yeah, help yourself. You already had that one. Yeah, you can highlight those. I gave you one last week that had like all the little things colored in for you.
Oh well. But that one's supposed
And I think-
to be over there. So.
Yeah, it counts as an intermediate, so it's worth like 8 or 4 points instead of that.
So I actually don't have a check mark here.
Well, there is no check mark there. That's why.
Oh.
Because there's no basic version of that question.
So sure.
Yeah, that works.
Oh wait, I missed one.
Yes.
That looks like there was one there too, was there?
Maybe. It's hard to tell. Sorry. Looks like there's one there.
I think.
I mean, I can go online and look up a better one.
Don't know. But that's gonna
Do you want me to look up a better one? I can look up a better one.
Well,
I just forgot to scan them last week, and so it's hard to see.
okay, so then we need to do. I got another one. For basic, we need to do binomial constant.
Binomial. So, because it doesn't have the question numbers in there. Last year, you know how on quiz 2 and quiz 3's check sheet it has like all the question numbers written in there?
Yeah, and that's what helped me.
I know. I did that last year for my kids, and they got mad because it's like, there's too much stuff on this page. And so I made it separate, where on one page you have the check marks, and then you'd look underneath it. Remember the beginning of the year? And you'd have the numbers underneath it. Thinking, this is nuts, but that's what they want. And guess what? I did that for you guys, quiz 1, and you hated it because you guys are smart like me, and you realized how dumb that system is, which is what we're suffering from right now. So you can thank the kids from last year. Turns out kids just like the thing they can't have. So binomial can I here, give me the form. Give me
I
the
don't
form.
see that one on my paper.
It's next to factoring. You don't need that because you got the check mark above it.
Okay.
So does anybody need to see any basic questions?
No. Besides.
The bottom box, yeah. Oh God. I'm sorry, but these basic questions are kind of the worst ones. Which is why we have to do them, because if they were easy, you would already know them and you wouldn't have to do them. Does that make sense? Right? We're only doing the hard questions. That's literally all you ever do in my class. It's always the questions you don't quite know yet. Because if you knew them, I would know that and I would have given you a check mark, right? So yeah.
Okay, it was really hot here and now it's getting cold.
Oh, Sophie Watts.
I'm just saying. It really
I'm just saying. Sophie, are you from Paulo your whole life?
Yep.
Really?
Yep.
Then why are you so gangster?
I'm not.
You are. You're the most gangster kid in the school.
Oh, yeah.
It's true. Straight out of Polo.
Joey belongs to the streets.
Joey was born on the streets. The streets raised him, taught him lessons.
Joey's cold too. I've seen him shaking.
Oh, yeah?
Yep.
Joey.
Right, Joey? See, I don't lie.
Do I believe that this is correct? I do believe this is correct. Okay, so how do we handle the 1/3 power? This does not mean divided by 3.
I was gonna say that.
It doesn't mean times by the top divided by the bottom. No, this is not 64 times 1/3. It's 64 to the 3rd power, kind of like 64 squared, except the exponent's a fraction. Okay, so here's what it means. It means this. What is the cube root of 64? In other words, what number times itself 3 times, because it's a cube root, not a square root, gets you 64? Well, 2 times 2 times 2 is 8. That's not enough. 3 times 3 times 3 is 27. The answer is 4. 4 times 4 times 4 is 64. Now, if you didn't know that, and someday you won't know how to solve a problem like this, you need a strategy for how to figure it out. Here's how you do it, okay? Let's break down 64 into its prime factorization. So in other words, what times what is 64? Give me
8
something.
times 8.
8 times 8. Yup.
That's what's up.
And I can break that down even further, right? Into 4 times 2 times 4 times 2. And I can break that down even further into 2 times 2 times 2 times 2 times 2 times 2.
Times 2.
Well, only 3 2s, right? 2 times 2 is 4, times 2 again. 2 times 2 is 4, times 2 again, right? So that's really 2 to the 6, wouldn't you say? I'm still here. Netflix. Okay, good.
It makes you fall.
Yeah, it does.
I know not for B, but I know the answer to the next one.
Me too. So, now that we're here, we can make this really simple. So, you know when I have something like 2 cubed to the 5th, it means 2 cubed times itself 5 times. So 2 times 2 times 2, times 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 2 times 2, 15 2s, right? Do you guys notice the pattern?
Yeah, I can't just multiply.
Yeah, because we're going to have 5 groups of 3. 2s, right? That many 2s being multiplied. So guess what? When we get to here, now we can do this. And that comes out nicely. What is 6 times 1? 6 divided by 3 is 2. So we get 2 to the 2nd. And just like Joey from the streets says, the cube root of 64 is 4. Joey from the streets. J Row. J Flow and J Row. I like it. So again, this is our strategy for figuring out if we can't just figure it out at the top of our head. Break it down until you get something that works out like this. Okay? Or until you can't break it down any further. Like 2 can't be broken down any further because it's prime. That's why we call it the prime factorization, because factors means multiply to make it up, right? And prime means you can't divide it up anymore. Okay. Do you know part B? You said you didn't. Okay. This is basically asking what number times itself gets you 100,000. So give me 2 numbers that multiply to 100,000.
100 times 100.
Oh my God, you're right. Now, we could break this down further and do 10 times 10 and 10 times 10 and blah, 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 right? But check it out. Isn't 100 times 100 just 100 squared? Say no more, fam. That's 100 to the 1st, which is just 100. And that makes sense because 100 times 100 gives you 100,000. And that's what this is asking. What number times itself gives you 100,000, right? 100, right? Ta-da. How you feeling? Gucci gang. Gang, gang. Teach me what they say on the streets of Polo, Joey. What are the cool kids saying now? Sophie. What? Everything?
I would say nothing.
Nothing. That is true. The coolest kids don't say much. It's the kids that want us to talk all the time and be like the center of attention that aren't actually that interesting or funny. What is 0 to the half power? Sophie!
0.
It is, because what number times itself gets you 0, right? This is the same thing as the square root of 0. It's 0. I know.
Why can't it be like a normal water bottle?
We're not talking about math, are we?
No.
Okay.
Nothing.
What number times itself is 121? If you don't...
11.
It is, but what if you didn't know? Well, you'd still have to figure out that 11 times 11 is 121 to break it down. And that's 11 squared. And 11 squared to the half power is just 11 to the first. So 11. Fine. Give me two numbers that multiply to 3,600. And again, this is half power because it's square root, right?
600 and 600.
Boo. You're close. 600 and 600 would have 4 zeros at the end. You mean 60 and 60.
Yeah.
So guess what? The answer is 60, right? Some people do 36 and 100, and then you keep breaking those down, and that'll get you the same thing. But yeah, well done. Here, cube root. That means 1/3 power. Break down 80. Something times something is 80.
It's something.
Good start, Sophie. Joey, finish him. Get in there, Joey. What times what is 40, or times what is 80? 2 and 40. 2's prime, but 40 ain't. Let's keep breaking it down. Looks like 2 and 20. Yep, I love how you said that. Now, I'm running out of room, so I'm going to write this next one as 2 to the 4th, because I already have 3, and I'm taking out another 2. So now I can't break them down anymore, right? 5 doesn't break down, 2 doesn't break down, they're prime. So now is the time to do this. 1/3 times 1 and 1/3 times 4. Well, 1/3 times 4 is going to be 4 over 3, which is 1 1/3. So 2 to the first, 2 to the 1/3. You follow me on that? Right? 1 and 1/3. That's 5 to the 1/3, because 1 times 1/3 is 1/3. So it looks like we just get 2. That's what this is, right? This is 2. And then we get both of these are cube roots. So 2 times 5 is 10. 2 times the cube root of 10 is our answer. So if you times this by itself 3 times, you get the cube root of 80. Or you get 80, I should say. This times itself 3 times gets 80. Because 2 times 2 times 2 is 8. And cube root of 10 times the cube root of 10 times the cube root of 10 is 10. 8 times 10 is 80. Boom. How you feel? Okay?
This is like your long list of numbers. So yeah.
We've lost Sophie.
Yeah, it's a bit.
That plastic is not a bunch of numbers.
Yeah, it is, because look how long that keeps going. It's just as long.
What times what is 81?
9 times 9.
Good, which you know is the same thing as 3 squared times 3 squared, right? Which is the same thing as 3 to the 4th.
Yep.
So guess what? 3 to the first, 3. Apparently the 4th root of 81 is 3 because 3 times 3 times 3 times 3 is 81. We did it! Basic questions, we're done. Okay, do we need to see any intermediates? We do. Do you want to do them or no?
Yes.
Fine, sure. All right, terms. This is a term. That is a term. We do not combine them until they're they're like terms. This is 5 5s, because 5 times 5. That's 3 4s. They are not the same. Okay? But if we think of 5 5s as 25, that's 25 1s. And we think of 3 4s as 12, that's 12 1s. They are like terms now, aren't they? 37. Thank you. Come again. This times this. We could like distribute the 7 and distribute the 9, but like, how about we don't? How about we just do 7 minus 9 first and get negative 2? Because they are like terms. We can combine them. And then we're going to take that and we're going to times it by 5 because 3 plus 2 is 5. Negative 10. Feeling good? Hi, we're live. Whatever you say is being heard on camera right now. And it's going straight to YouTube. Hi. We're working on quiz 1.
No, you don't.
I'm going to make a copy of it when I'm done and hand it out to everybody, so you don't need to write anything. I'm sad I don't have my soundboard hooked up. It would be more fun. I could push the audience screaming and clapping button, like, you know, canned laughter. ASMR.
Can you actually hear me?
Yeah.
Why can't I hear myself, like the noise?
Because you don't have a headset on to be able to listen to what you sound like.
That's no cool.
Yeah. Otherwise, it would be coming out of the speakers and back into the mic, and you get feedback.
I also think I'm trying to get sick.
That's not good.
Just me on that.
She did.
I told her my locker number 2 times.
Ava Lynn. So I'm going to make a copy of all this, so you don't need to write anything down, okay? You can just watch the show. Or do whatever you're going to do. This one right here. Let's get these terms together, because if we think of them as actual numbers, like ones, we'll be able to do it. 3 to the third power means 3 times 3 times 3. That's 9 times 3, right? 27. Minus 2 to the fourth. What's 2 to the fourth? 2 times 2 times 2 times 2. Everybody, it's a live studio audience.
Wait, what?
That's okay. You're live.
I've said some really job anyway, so.
Yep, 16.
I'm so smart. That's what's up.
Now, to reiterate, this is all one term right here, because look, the parentheses, you ignore the minus sign inside and you just say, look, treat this all as one idea, something times 6. That's one term, right? For the love of God, do not do this first, okay? This is all one idea. The 9 is separate. We do that last. So 27 minus 16 is 11. Still, see how there's no plus or minus sign between the 11 and the 16? 66. Now they're like terms. That was 11 sixes. That was 9 ones. Now we have 66 ones and 9 ones. We can combine those to how many ones? Well, if I take away 6 and then take away 3, 57. Everybody wants to touch that 9. Leave the 9 alone. Stop touching the 9. Okay? That's my advice. These are intermediate questions on quiz 1. We covered some of the basic questions that were about roots. Sorry you missed that, but, you know, such is life. You guys aren't even supposed to be here for a while. Like another hour. So,
You're
well,
done with basketball.
welcome. How was it? Did you dunk? Did you finally dunk on him?
No, we probably done that a lot today, actually.
Oof. Sorry, don't talk about it then. Because we're live to YouTube. At least we will when I upload this. And we're live to the Meet, Google Meet, which nobody's in. Although Lydia's totally going to be back.
Like over like an hour.
Yeah, totally. And we all believed her. It's okay, no shame, right? Like, you don't have to be here. Just watch it later. Or don't at all. No shame. Do we want to see this one?
I don't know.
Do you notice that they're the same numbers? I just grouped them differently. Do this, then that. And this is not 6 squared, right? Think about what this means. This means 2 times 3 times 3. That's
So
2
2
times 9, not 6 squared. Don't do 2 times 3 and get 6 and then square it. No. 20 minus 2 times 9 is 20 minus 18. That's 2. Again, terms. 20 minus whatever this is. What is 2 times 3? It's 6. So now we're squaring 6. Again, that came from here. We're not including the minus sign. So that's 20 minus 36. It's going to be negative 16. Here, we're treating all of this like one term, and then we're going to square it. Okay, cool. What is 20 minus 6? Because that's what this is. And then we're going to square that. Looks like 14 squared. Let's figure out 14 squared in our heads. And by 14 squared in our heads, I mean this. 14 times 10 plus 14 times 4. right? That's 14 14s, right? 140. 40 plus 16, 56. 196. It's apparently 14 squared. How do you like them apples?
Good enough.
Can I get a whoop whoop? Thanks, Evelyn. Evelyn gets me. This one. We know from the beginning you can move things around as long as you keep the minus signs. Joseph, this one's for you. See how the 27's negative? Joseph, do you see how the 74 is positive?
Yeah.
See how the 74 isn't positive anymore? This is not the same, okay? Do you see how the 27 isn't negative anymore? They are not the same. Do you see how the 74 is negative and it used to be positive? They are not the same. Do you see how, even though it's in a different spot, the 74 is still positive? Do you see how the 27 is still negative? Turns out something minus something is the same thing as the negative version of that plus that. In other words, here, negative a plus b is the same thing as b minus a. You could do b minus a. So if I had negative 7 plus 4, it's the same thing as 4 minus 7.
So it keeps.
Yep. So it's C.
You had me scared for a second.
Yep. No, you're good. I just couldn't find it. Yep. That's it. And that's a super useful property because you might not like 4 minus 7. Or maybe you might not like negative 7 plus 4. You can change them, right? Just flip them. Totally fine. Move things around. PEMDAS won't teach you that. Now, will it?
Nope.
Mic drop.
Oh.
Thank you. Get his ass. Anyway. Oh, no. Now we can't have this marked for kids. I said a bad word. This guy.
You're done.
Timesing and dividing. We can do in any order we want. So instead of doing 109 times 2, then dividing by 8, then timesing by 4, and then dividing by 109, what if we did 109 divided by 109 first? See how this says divide by 109? 109 divided by 109 is what? 1, otherwise known as 1 over 1. 1 times 2 eighths is 2 eighths. 4 divided by 1 is 4. How about we times by the top, divide by the bottom? 8 divided by 8 is 1. A lot easier than doing 109 times 2, then dividing that by 8, then timesing it by 4, then dividing by 109, right? It's 1. It's 1. PEMDAS won't teach you that now, will it? Sorry, I don't have my soundboard up. I wish I did. If I did, I'd have an air horn button and a bunch of Michael Scott quotes from The Office. You guys don't know that show. What do you guys watch now? What's your funny show that you watch? The Office? Timeless classic. You don't watch anything? Evelyn is either sleeping, running, or studying. That's all Evelyn does.
Honestly, pretty bad.
I love Pretty Little Liars. I watch that all. No, I've never seen it.
You watch Friends?
No, I'm more of a Seinfeld guy.
Man!
New show Wednesday.
I have not. I've heard it's very good though.
It is good.
Yeah.
I'm literally on episode 2 because I don't want to watch it.
Exactly.
Words are hard. Basically, it's saying, look, 7 minus 6 is not the same thing as 6 minus 7. Do you know why? Because look how the 6 is positive now and it wasn't before. Right?
Yep.
Okay. Is it ever possible to switch the order of numbers like this and it would be equal? So in other words, will this ever be true? Generally, it is not. However, there is a situation where it could be. If A and B are both 0, or better, if A equals B. Because think about it. If A and B are the same number, anything minus itself is 0. Anything minus itself is 0. So both being 0 is like part of that, right? Because both numbers are 0. But both numbers could also be 1. 1 minus 1 is 1 minus 1, right? Or 2. So that's all. Cole expanded the product. Right? Distribution. That's what he's doing. He's taking this, and he's doing negative 3 times 4. Right? That's what he did there. And negative 3 times negative 7. That's what he did here. Now, here's his mistake. Super common. Super common. See how I put a minus sign here? If you're going to include the negative with the 7, you have to put a plus sign there. So your options are to either do negative 3 times 4 and get negative 12, and negative 3 times negative 7 and get a positive 21. Or you do negative 3 times 4 and get negative 12. Minus negative 3 times 7. What's negative 3 times 7? See how I didn't take the negative with the 7? Negative 3 times regular 7. What's that? Negative 21. But you can't do both, Cole. He did both. He did both. Both. Do you say both or both?
Both.
Both with an L.
Both.
For the longest time, I thought, I don't have an accent. Everybody else has an
You
accent.
do.
Everybody does.
You do.
Everybody has an accent.
The way you say 1,000.
Yep. Everybody has an accent. It's a Midwest accent. It's true. I used to say, I will fix a bowl of ice cream. And I didn't realize that that was like a Southern thing. My family just always said it instead of make a bowl of ice cream or something. Or like, scoop a bowl of ice cream or whatever. How embarrassing for me. But yeah, we do. We say, instead of saying or, we say
Who even says
What do you mean?
bowl?
What do you mean by
Just like get to my screen.
like this or that. You say it. This or that. You don't say or. We have a Midwest accent.
Yeah.
Say 1,000.
1,000? What's so funny about
Noticed
that?
Since day one.
1,000?
1,000.
1,000? Oh, sorry. Yeah, my family is from Southern Illinois
Why
and
does everyone think of
St.
That's
Louis.
where I went like 2 weekends ago.
Nice!
I feel like people think Americans don't. Like people in America think we don't have an accent.
Everybody all over America has accents, including us.
Texas.
British doesn't have accent because
North Carolina.
It's still an accent. It's a way of saying things.
It's
Doesn't mean it's not the original or whatever, right?
English accent.
I suppose.
You're just the Joey accent.
Joey. Do you guys know Joey was born in the streets?
You belong to
Belongs to the streets.
He's gangster.
Joey, we're going to get you some chains. It's going to be sick.
Yeah. With the braces.
Hello, simplify the following fractions by dividing out common terms. Could you solve this by doing 6 times 13 times 9 and then dividing it by whatever 13 times 6 is? Sure. But you know division and multiplication can be done in any order you want. Suck it, PEMDAS. So it's all multiplication and division. So we can do it in any order we want. 13 divided by 13 is 1. 6 divided by 6 is 1. So we just get 1 in the top times 9, which is 9. 1 in the bottom, 9.
Boom, done.
Boom, done. Boom, roasted.
Cancelled.
You're done.
Year.
Need to update my soundboard to, not millennial. What are you guys? Gen Z sounds. All my sounds are built for the seniors, not you guys. All right, compute each without a calculator. What does it mean to take something to the third power? Times it by itself 3 times. So that's what this means. Looks like it's going to be negative 1,000. How are you feeling about that? Remember, you are live.
Nobody can hear me whisper.
Yes, they can. I can literally see the bar moving as you talk.
Literally, everyone's gonna laugh at that. So.
Yeah, I can see the bar moving when Joey talks.
Well, just like blurt it out what I just said.
No, I'm good. I'll just go back and listen to it later.
It's really funny.
I won't. All right.
She laughed too.
That is negative 1,000. Do we agree? 3 negatives makes a negative?
Mr.
1,000. 1,000.
1,000.
Cool. Over here, this is different.
Positive.
This is going to come out negative still. However, it's for a different reason. Because this means 10 cubed, then negated, right? If I had 5 times 10 cubed, you would not say, ooh, 50 cubed, right? We talked about that earlier with the 6 and the 2 and the 3, right? So this is really negative 1 times 10 cubed. So it's not the negative that's going to get cubed. We have negative 1 times 10 times 10 times 10. Still negative 1,000, but for a different reason. This will always come out negative. Whereas this, if we had an even number of negatives, it'd come out positive. Kiddos, I'm doing this for you. Are we sure we still need to go, or do we need to take a break?
Oh, well, we're still going.
You sure?
I took a 1-second break because
Oh,
I was
okay.
figuring out what time I was leaving.
Oh, that's important.
Yeah.
Again, just asking because I want to make sure we're using this time to the best of our ability, right? And if not, we can just take a break, right?
William's here.
Hello, William.
Guess who's back?
Back again.
William's back. William's gone. Bye, William.
Before we leave today, can we all the basic for number 2.
Oh, for sure. That's the plan. Should we see these or no?
I have a question. So for tomorrow, if I do like the quiz number 1,
Mm-hmm.
and I have all my basic, all my intermediate, and 1 advanced,
Yeah.
should I just not do number 1?
You should do the one that needs the most work. Does that make sense? That's gonna have the biggest effect.
You can take quiz, whatever you
If you're killing it on quiz 1,
But I mean, like,
you could do all 3 quizzes if you wanted to. We have enough time. It's 80 minutes or whatever it is.
but do you think I should just finish quiz 1 and do all the ones?
No. So I was talking about this earlier with Joseph. The basics are the heart of the problem. So going from not a check mark in a single horizontal box range thing, right, in a single category, to a check mark in the basic box is a 60% increase, right? You're going from 0 to 60. That's a lot. And then the jump to the next box is only from 60 to 80, right? So it's better to get all the basics than it is to jump around and get like the more advanced ones.
Yeah. Well, like, what if I get like a whole?
Wow. Then that means you're going to get like 100% for semester 1 if we're talking.
Just for one test. Not for all.
Yeah, and that's half your grade if we're talking chapter 1, right? Which is good. But you probably want to balance out quiz 2 and quiz 3 a little bit more. It depends on who you are.
If I like do like a quiz, like so for quiz 1, I do all of it. Like I check off all the ones that I had checked off, and I just do like 9.
But I need to reiterate how difficult that is. That is incredibly hard, right? And not only that, but it's a lot of effort to get very little improvement because you've already got a bunch of boxes checked on that, right? Does that make sense? Right, you might want to spend less effort getting more important points. But you do you.
If you
Mr.
haven't,
Method.
Hi.
Let him go first.
Joseph, I will let you go first. Just this once!
if you haven't answered a question before, or if you just have gotten some X on it this Wednesday, can you even get like enough check marks on your one sheet to get enough? Or
You would have to convince me very strongly that you clearly understand it. And that can be done with one go, but it doesn't leave much room for error, right? If there's like, they kind of made a little weird mistake there, is that going to happen every single time, or do they actually know this? You're right, I can't give it to you. So, yes, that is the downside, right? If you have not ever attempted a question before.
Always gotta take a couple of X's on it.
Yeah, if you've never attempted a question before, it will be difficult to prove in one go that you understand it. Yes, this is true. So again, I would work on stuff that's more basic focused, get all the basics taken care of first, and then worry about other things. Anyway, you want to see these two?
No.
1 over 4 cubed. This is going to be negative 4 cubed, right? Negative 64. What about these?
That was one of the problems that I showed on my thing.
I don't
What's-
even remember that.
Because I did it, and it was that exact same problem.
Boom. Roasted.
Yeah. So,
Wow.
Wow.
Evelyn's dangerous, I'm finding out.
My mom asked me if I need anything to prepare for the blizzard. I go Pringles.
There's a blizzard?
There's a
I
blizzard?
guess.
Yeah, there's coming one second.
Okay.
I told
Just in
Pringles.
time for me to go home and not be able to go anywhere.
Grandma said that you should spend the night over stuff. I said no.
You and Evelyn are friends?
That's right.
Oh, that's nice. That's so
That's
nice.
why she's so feisty with me.
That makes sense. You know, when you know 2 people and you're like, man, they're cool people. And then you find out they're friends, you're like, oh, that's so great. You guys found each other. All right. These 3, yes or no?
hey,
That's what my best friend is.
Calderoni. I can tell.
No, she's not me. Abraham. No, she's not me. I had her. I don't know her whole life.
All right, so yes or no?
Can I take my Be Real?
Yes.
Thanks.
Let's go. I didn't ask him. I
Ready?
didn't do it.
Mr. Mack, you're gonna be the back of it. Ready? You're gonna be the green screen. Ready, guys?
You ready, guys?
got another one.
Oh my God.
It's okay.
Just like you're late. You're late to the party.
Joey, why don't you have Be Real?
I keep my phone in my locker.
Joey.
That's not
That's so
okay.
weird.
And I don't have the real installed.
Yeah, neither do I. Good for you,
It's free,
Joey.
though.
But I still have to install it.
Yeah.
That one.
It's just one button. But it's okay, I'm not gonna make you do nothing.
No, you have to go to App Store, then
And then they collect all your facial data so they can use it. Oh, it's not good. Not
Let the
good.
world see my beautiful face.
Not good. But like they're gonna.
Have you checked this stuff like check the terms and policies? They can check your stuff in other apps.
Yeah, it's not good. He reads, that's why.
If I get kidnapped, I get kidnapped.
All right, children. For the final time, these ones, yes or no?
Yeah.
No.
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 All right, this one. Do we know the difference?
Yeah.
Yes.
No.
All right.
Why are you putting my video?
This means -5 times -5 times -5, which in this case will come out to -125. This will also be the same answer. It's a coincidence, but it does mean something different, right? This means that. This means -1 times 5 cubed, which will come out to the same answer this time. But I want you to notice, this will always come out negative, right? Whereas this, if we had more -5s in here, like an even number, right, it would come out positive, right? Cool.
That one used to be a pump.
I'm guessing this is a yes, right?
What is a pump?
I know that one.
Anybody? I'm guessing it's a yes. Joseph?
Jolena.
You guys all need this, so I don't know why you guys are acting like you don't. All right, check it out. 1/3 power. Let's break it down. If I keep breaking it down, -2 times 2 times 54. That's -2 squared times another 2 and 27. That's -2 cubed now. Times 3 times 9. That's -2 cubed. Notice that's 3 squared, so this is really 3 cubed. And now, it's time to apply this. We know how this works. -2, when we take that third power and times it by 1/3, we get 1. Cool? And then 3 times 1/3 is again 1. So this is going to be -6. Turns out -6 times itself 3 times gets you -216. Cool? Wonderful. What are you doing? Sneaking. Yeah, go ahead.
Sophie, is
Sure.
that one about, is that Gator about the size of the equation?
I made
Gatorade.
She said that's the size of the
Do you like
equation.
water boy?
I've never seen it actually, but I do quote it all the time.
What?
I probably shouldn't be touching that. Part of it was touching somebody's gum, but that's not the part I touched. So it's okay.
That's lovely.
This one, let's break it down. 2, 3, 5, 2, 8. 2, 150, 250, or sorry, 1,500 plus 250 is 1,750. 1,750 plus 14 is 1,764. How am I doing this? Anyway, I'm going to take out another 2. That's 3 2s I've taken out. That's 500 plus 350 is 850 plus 32. 850 plus 32 is 882.
After this, I got a question.
I got to ask you a question. 441. Oh, no. 3 goes into this. Do you know why? Because 4 plus 4 plus 1 adds up to 9, and 9 is divisible by 3.
Okay.
You can always check a number if it's divisible by 3 like
Is
that.
that 49 or 41?
441. So 4 and 1 adds up to 9. 9 is divisible by 3, so that means 441 is divisible by 3. It's also divisible by 9 because it adds up to 9. But I'll divide out a 3. We'll end up dividing out another 3 because, like I said, it is divisible by 9. 3 times 100 is 300. 3 times 33 is 99. So 199 with 42 left over. 14. 199, 113. Do I agree with that? No, I do not. Is it 117? I think it's 117. 330 plus 21. No, it's not. Ah, that's not good. 300. And, oh, hold on. Maybe it is. 300. No, it's not. So 199. No, 133 plus 14. 147. There we go. I knew it had an end in a 7. Guess what? That's also divisible by 3 because guess what? 7 plus 4 plus 1 is the same thing as 12, and 12 is divisible by 3.
Do it.
So we've taken out another 3. If this was 150, 3 times 50 gets that, right? So 3 times 49 gets this. So that's 2 to the 4th, 3 squared, 7 squared, all to the half power, and those are all prime numbers, so now it's time to apply. That's 2 squared, 3 to the 1st, and 7 to the 1st. 4 times 3 is 12, 12 times 7 is 70 plus 14, which is 84. So, what number times itself twice gets you 7,056? 84 times itself twice will get you 7,056. I feel like I'm not doing this for anyone other than me.
That was
That was
even in here.
confusing.
Well, do you want to see it or no?
No.
You said you had a question, Sophie.
I forgot. It wasn't.
Oh my god.
It was not important. That's why I said.
Okay, are we doing the next ones or no?
Yeah.
Okay,
That was
guess what? These aren't actually that hard. So, imagine that this wasn't the problem I gave you. Imagine...
times by the top and by the bottom.
No, this is not 4 times 5 halves. We discussed that earlier, actually, before you were here. That's 4 to the 5 halves power. Now, check it out. Big brain play. This is the same as that, right? Because when these multiply, we get 5 halves, right? But this is an easier question. 5 times 1 divided by 2 is 5 halves, right? So 4 to the half power, what is that asking? What number times itself is 4? So this is really 2 to the 5th. And 2 to the 5th is 32. Done. So you need to rethink of these things in ways that make it easy to do in your head. Instead of 27 to the 5/3 power, I'll do 27 to the 1/3 power to the 5th. What's 27 to the 1/3 power?
9.
Nope. What number times itself 3 times gets you 27? 3. So this is 3 to the 5th. That's 81 times 3, because, right, there's 5 3s, so 9 times 9 times 3. So 81 times 3 ends in a 3. 243. -1 in parentheses, that matters, right? If the negative's outside, that changes things. To the 36th power, to the 1/5 power. Same thing, right? -1 to the 36th. There's an even number of negatives, right? So it's going to come out positive. So 1 to the 1/5 is what we're doing. What question is that asking? What number times itself 5 times gets you 1? What number times itself 5 times gets you 1? Nope.
What number times itself?
5 times gets you 1.
1.
1 times itself 5 times gets you 1. Yeah.
Dang it.
Right? Does that make sense?
No.
1 times 1 times 1 times 1 times 1 gets you 1. So again,
Negative, or the 36 makes it positive. No, 1 positive.
because if there's 36 negative ones being multiplied, there's an even number of negatives, and so they'll divide out, right?
Yeah.
Yep.
That was my thing.
There you go. That's the important question. Wait a minute. He's so happy to see you. He's smiling.
Oh, he is a unibrow.
He does have a unibrow. He's sensitive about it. He's going away now.
Tell him I'm sorry.
He said some very not nice words.
Also,
All right, so I'm going to think of this like this. And the reason I'm doing this is because I know that what number times itself 3 times gets me -8? -2. So this is -2 to the -4th power. Well, if it was to the 4th power, it would be -2 times itself 4 times. But this is just going to be 1 over -2 times itself 4 times, which of course is 1 over 16. And it's going to come out positive, right? Because there's an even number of negatives. 1/16. How you feeling? Gucci gang?
Feeling good.
Gang, 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 gang.
I want to try that because I want to see your reaction.
Are we doing it or no?
Yes.
Okay.
Wait.
No.
No.
Why?
Because I can
Because
figure
I
it
know
out.
everything already.
Is there a number that equals 4 to the 1/4? It's asking what number times itself gets you 4. But you have to times it by itself 4 times, right?
Well, you can break it down far enough in decimals.
It's going to be this number. So, that's the same thing, right? Which is this. Are you agreeing with me, right? That's 4 to the 4th, right? That's 2 to the half. That's just the root of 2. The root of 2 times itself 4 times gets you 4, because root 2 times root 2 is 2. Root 2 times root 2 is 2. 2 times 2 is 4. Is there a positive or negative number that does this? What number times itself 4 times gets you a negative 4?
Nothing.
Because there's no way to multiply 4 things and have it come out negative, right? 4 of the same, right? Because they're either all negative, which means it comes out positive, or they're all positive, which means it comes out positive. So no. No. I have that on the sound thing, the magic conch. I do. I just don't have it looked up. Check this out. Hey.
Sorry. Just throwing things at me. I didn't mean to.
Now, you know how this works. First of all, that's 2/3, right? If I had 2 cubed times 5 cubed, wait, oops, sorry, that doesn't work. Let's do this. What's t cubed times t to the 4th? How can we simplify that?
T to the 4, 5, 6, 7.
Yes, t to the 7th, right? So in other words, the trick is you add them, right? And the reason is because there's 7 t's being multiplied, right?
Yep.
So how many 5s are being multiplied here? Well, in total, I'll have 6/3 or 2, which means 25. So again, that's 2/3 power, right? You add them in this case. This one's easy. -8. Guys, you know I have this pre-recorded, right? Like I did all of these problems on YouTube, and you can just sit home and watch that at your own time, right? The whole point of you being here is so you can ask questions, or at least pay attention so you can go, wait, I don't get that. It's okay. You don't need to be scared.
I have. In the beginning.
Okay, I just want to make sure, because if not, like, you could go home, man. Like, I'm not
going home
mad.
at 5:30.
Like, I'm not mad. I'm just trying to take care of you.
Can we put the test number 2?
Do we not want to see these?
Well,
They're really not that bad.
yes, we do.
All right.
Well, I'm not gonna take this technical.
Let us break this down. This number's not divisible by 2. So what gives?
This one's worth more than that.
I mean, depending on how much you're missing from it, right? If there might not be much left of the pie. If you've got 1,000,000 check marks on it, there's not much of that improvement to do,
I
right?
do.
Okay. So check it out. This is not divisible by 2, so we can't break it down by 2 times something. Does 3 go into it?
No, because you can't divide anything by 3 and get
It only goes into itself.
an answer.
3 does go into it. For those of you following along at home, you remember what I mentioned about 5 minutes ago. There's a trick for testing if it's divisible by 3. If we add all the digits together, what's 1 plus 3? What's 1 plus 3? Plus 2 is?
6.
Plus 3 is?
9.
Is 9 divisible by 3? Then this number is divisible by 3. So it's 3 times something. I know 3 times 333 gets me 999. So I still have 324 to go, don't I? See how I'm logicking this? 3 times 33 is 999, right?
Yes.
So I still have, after I've done 333 threes, I still have 324 left to go, right? Right, I made it to 999. I still have 324 left to go. 3 times 100 gets me 300. So now I still have 24 to go. 3 times what is 24? 8. So altogether, that's 1,323. So I needed 451 threes. 1,200 plus 150 plus 3. Yep, checks out. Oh no, this isn't divisible by 2. Is it divisible by 3?
Yes.
What's 4 plus 5?
9.
What's 9 plus 1? It's not.
That's 9.
It's 10. 4 plus 5 is 9.
I thought you were saying 5 plus 4 is 10. Or not 9. No. Okay, continue. Sorry, guys. I had a confusing moment.
Okay.
This should be a 4. That's why.
Oh.
100, or that's 430 plus 11, 441. There we go. So now it is divisible by 3. I was like, oh, maybe it's divisible by 7. And no, it wasn't. So I knew it had to be wrong over here. So if we take out another 3, now we're at 2 3s. How many times does 3 go into 441? Well, it goes into it 100. Oh, right over here. 3 times 100 gets us 300. And I have 141 left to go. 3 times 33 gets me 99. I have 42 left to go. 6 times 7 is 42. So 3 times 14 is also 42. That's our number. So we have 147. Is that divisible by 3?
Yes.
Yes, it is, because 1 and 4 makes 5, 5 and 7 makes 12. 12 is divisible by 3, so the whole number is divisible by 3. 3 times 33 gets us to 99. I got 48 left to go. 3 times 10 gets me 30, so now I'm up to 43, and I've got 16 left to go. No, 15. Oh, I lost track of it. Darn it. 3 times 33 is 99. 48 left to go. 3 times 10 is 30. 18 left to go. 3 times 6, there we go, is 18. So 49. And what's nice about 49? It's 7 squared. I knew there was a 7 here. So it was divisible by 7. I just couldn't do math. All right. Although that number wasn't the one we had before, which, yeah, okay, cool. So this will come out to 3 to the first times 3 to the half. Because look, when we times this, that becomes 1.5, right? This becomes 1.5, right? 3 over 2 is 1.5. And that becomes 7 to the first. So it looks like we have 21 root 3. This is 676 over 100 rooted. Bottom's 10, because root of 100 is 10. 676 is divisible by 2, so I could rewrite that as 2 times 3. 35 plus 3 is 38. 2 times 2. 150 plus 15 is 165 plus 4 is 169. What is the root of 169? 13. 13 times 13 is 169. Nice. So that comes out to 2 times 13 over 10, which is 26 over 10. Simplify or don't, I don't care. Do we want to see this one? This one's easy.
No, because that one's too even. That one's easy.
Done. This one. It's going to come out negative, right? Because there's 3 of them. 27 is 3 cubed to the half power, and we're cubing it, right? See how that is? 27. Half power. Cubed. Looks like 3 to the 3 halves, 3 to the 9 halves. So in other words, if we do, oh, whoops, I don't know if you can saw that. That's negative 3 to the 4th and negative 3 to the half, because that's 4.5. And it should come out negative. Sorry. That's going to be 3 to the 4th is 81. 81 negative root 3. A little.
And you know how long he was here for?
2 in the morning. Yes or no?
Oh. Because we mean a lot to him.
Yep, that's right.
I will see you later. Goodbye, Mr. Mac.
Do see.
What's the 4th root of 625? 5. What's the 4th root of 32? 2. Done.
Oh.
Right, because 2 times itself 4 times. Ah, 2 times itself 5 times is 32. Ah, that sucks. What? Bye, I'll miss you. That's 2 to the 5th, so 2 and this. There we go. Problem solved. That's 2 to the 5th. If I take the 4th power, I get 2 to the 5/4. So 2 and 1/5, or sorry, 1 and 1/5. There's 1, there's 1/5, 5. This one right here, what times itself 3 times gets you negative 0.001? That one. If you times it by itself 3 times, you get 0.001, right? It moves the decimal place over.
Oh.
Done. Suppose n is a positive integer. What must be true of n if it is not possible to simplify the cube root of n?
Mr. Mac,
Hello.
go back up, please. So, like, if you don't you like times it by 100 to move it like each place? Like,
You times it by 10 to move it each time, yeah.
oh, like 100 to move it 2 places.
To move it to the right, or we divide by 10. Dividing by 10 is the same thing as multiplying by 0.1.
Oh.
Yes, so 0.1 times 0.1 times 0.1 moves it over 3 times.
Oh.
Mm-hmm.
Okay.
Yep. Suppose n is a positive integer. What must be true about n if it is not possible to simplify this? Well, normally we have like 2 cubed inside there, and then we do the 1/3 power, and it goes away. It comes out nicely, right? That means n, if we cannot simplify it, it has no factors that appear 3 times. So in other words, right, if I could simplify it, let's do a number like 27. Why does this simplify? Because 27 to the 1/3 power can be rewritten as 3 cubed to the 1/3 power. And see how there's 3 of them? These multiply and it comes out to 1, which means it's nice. But imagine if we had a number like 9 in here. Well, that's 3 squared. When these multiply, I get 3 to the 2/3. Well, that's just 3 squared, cube rooted, otherwise known as this. See how we don't get anywhere, right? Nothing breaks out of here because there aren't 3 or 6 or 9 of these. So when this multiplies, we get a nice number. So nothing in here must have 3 factors, right? We only had like 2 factors or something. No 3s. This one, yes, no, maybe so. No, I think we're ready to stop on these, right? Now, the good news of this one is it's really not that bad. You simplify it, and they're all like the same thing, and you can add them together, but whatever. That's fine. Oh, but we were so close! Do you want to do them anyway?
No.
Okay. Joseph? Evelyn? Sure, we're so close. No? Okay, it's for you. I did them on the video last night, or 2 nights ago, or whatever that was. So. We move on to quiz 2? Joseph's like, yes, finally.
And Sophie wants the original copy of
Well, I'm going to make a copy of it for everybody, but yes, I'll give you the original.
You want the colors.
You want this copy back then?
Where do you want my test papers?
Number 3.
Is that quiz 2?
This is 3. This is like the only copy.
Oh. Okay, sure, yeah.
Where do you want these?
I will take them. Thank
Okay.
you. Because Sophie's outie.
Yeah.
Mr. Mac, do you want from today your original copy?
Yeah, and I'll make copies, and then I will.
This is a blank number 1.
Okay, blank number
Here.
somewhere in there. Yep. Right there. Perfect. All right, I will scan these. Don't me. All right, we're looking at quiz 2 now. Is that the plan?
Yeah.
All right, cool. And I will make copies for everybody when I'm done, so you can just kind of watch the show. Although you guys are letting your minds wander a little too much, I think, when we just watch the show. You want to take a break first? Or you want to jump right into it? Because we technically only have 30 more minutes before Ayana gets back, and we all start going nuts for our last hour, 6 to 9. And then I got to make all the quizzes. I have to make sure the numbers come out nicely, and then I got to print them out. It'll be fine. It'll be fine. Oh no! I love your backpack. So pretty. All right, just me and Joseph. Joey from the streets. Joey from the hood. Joey from the block.
We belong to the streets.
Bye bye. Joseph, what ones do you want to see? It's just you and me.
Can I just bring this paper to you?
Yeah, that's fine. Oh yeah, this has gotta go in a thing.
And I figured you would use that. This one.
Yeah?
This one.
Cool. Joseph. Oh man. Why didn't the people from 6 to 9 just show up now? Maybe they did. Maybe they didn't.
I think they were at basketball and they decided to.
Oh, I'm gonna be so tired. Why did I let this happen? All right, so we need to look at 221. This guy right here. All right, good news. It's all addition and subtraction, so you don't even need the parentheses. And you can't combine x's with regular numbers, but you can, oh God, you can combine x's with x's and numbers with numbers, and we're adding, right? So take that and add that to it.
Wait, I thought you had to do. I was taught. I thought that, but if you move it across the center point, it swapped its value. So like that would make it 3 to 5. It would make it negative 3.
I'm gonna murder myself. Okay, anyway, this is not child safe anymore. I'm gonna have to edit this out, which I won't. Hi, YouTube. Yes, that's true if you're moving things across to equal signs, but like, yeah, but like, that's just like a trick, and now it's screwing you over because there isn't an equal sign here.
Yeah, I keep on trying this, but
I mean, sure, but like, that's not really learning. That's just random. We speak no evil. Okay, anyway. 3x's plus 5x's. 8x's. Negative 8 plus 7.
that ain't 1. No,
Yeah.
yeah.
Yeah. 3, and we're adding. 3 plus 27. Those can go together. Negative 3x's plus negative 19x's. In other words, I'm just combining them. It's going to be a total of negative 22x's. Right? If I had 1x and 19, you get 20. So, right, 3 is going to be 22. And that's it. Pain. Pain.
I'm sorry.
No, it's not your fault. It's just like, oh God, I know why we do it, because it gets them the right answer on the test, but it screws you over later. All right, this next one.
It worked for standardized testing, I guess.
Pain.
Sorry.
No, it's okay. Oh God, I hate standardized testing and what it has done to education. It has made us actively stupider. All right, not your fault. Not your fault. That's the way we do things. T times T times T times T times T times T times T. Clearly, this is T to the 4th or T to the 7th, right? Okay, cool.
Oh, this is so much simpler.
Yeah, and it's not. Oh, I just add them. No.
I was doing T times T times T over T times T times T.
I don't know why you're dividing. I know.
And I was like one
Yeah.
T equals 1.
You're looking for like tricks. If you understand what's actually going on, we're timesing T times T times T times T times T times T times T. There's no trick. It's just literally we're timesing 7 T's, right?
But is A, B, C, and D its own individual check mark?
It is all in the same box as the last one. Yeah, there's a ton of them in there. So it's all part and parcel.
Like on your main check marks?
Yes.
Is it A, B, C,
Yes,
D,
yes,
E,
yes,
O?
yes, yeah, on my sheet, yeah.
That gives me some hope to get some.
So this right here, we're just timesing. That's 16 times x times 4 times x times x times x times x times x, right? Times in any order you want. That's 64 x to the 7th. I know. No, it's okay. This happens every single year with every single kid. It turns out when you understand what it means, it's like, well, duh. And that's how it should feel when you really understand something, right? So don't feel bad. That means you're really getting it. This means take that times itself 9 times. I'm not writing that out. Imagine I had y to the 5th times y to the 5th times y to the 5th. I'm going to have 9 groups of 5 y's all being multiplied.
So 9. So you just multiply.
Right? Why am I multiplying those numbers? Because I'm having 9 groups of 5, right? Does that make sense? Okay, cool. This, I'm having 6 groups of this. I will write this out. Oh God, why is everything all weird? Stop being weird. 3 3x squared times 3x squared. I'm literally going to write this out. Times itself 6 times, right? And it's that whole thing being times by itself 6 times. Here, it was only the x's that we're getting to the 5th, right? Not, right? Okay, cool. 1, 2, 3, 4, 5, 6. So now I've got 3 times 3 times 3 times 3 times 3 times 3. That's 27 times 27. Or if I'd rather, 81. Yeah, 9 times 9 is 81. What's 81 times 9? Well, I know it ends in a 9 because 9 times 1. And 9 times 8 is 27, so 279. And then I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 x's being multiplied by each other. Right? So there we go. Here we go. This guy right here. There it is. This is p to the 7th. 1, 2, 3, 4, 5, 6, 7. And we're dividing by p squared. Guess what? They divide out and become 1s. And 1 times p to the 5th is just p to the 5th. And 1 times 1 is just 1. So that's p to the 5th. Are you following me on that?
I believe so.
Those are just 1s now because they divided out. Anything divided by itself is 1.
I would have thought you would have just not done p to the 5th and just like cancel the p and turn it to 5.
No, because remember, p to the 5th means... So think about this. When I divide those out, I've got 1 times 1. What's 1 times 1?
1.
Good. 1 times p, what's that? Yep. So what's p times p times p times p times p? Well, that's clearly p to the 5th, right? And then on the bottom, we have 1 times 1.
So you don't know if p is 1.
Yeah, exactly. It could be anything, right? So it's whatever this is to the 5th. Cool. Here, first off, I can factor out a 5 from that 25, and I can factor a 5 out from the 30. And those will divide out, right? Cool. That's 1 over 1 now. I can just basically ignore that, right? Because 1 times 5 is 5. It's like it goes away. 1 times 6 is 6. It just basically goes away. And then this, you know that all 3 of the z's on top are going to divide out. And 3 of the z's on bottom will divide out. So all the z's on top divide out and become 1s. I can just basically ignore them, right? And then 6 times the remaining 4 z's. Okay. Negative exponents, how do they work? Well, we know 3 to the 1st means 3.
Is it just the same, but you make it negative to positive?
Yep, that's the pattern, but that's not why it works. Remember, here, 3 to the 0th is 1. So we're dividing by 3 as we go down. So I need to divide 1 by 3. It's 1/3. And you'll notice that is this over 1, right? That's like the pattern, but that's not the reason why. Nope, just asking if I'm still there. So that's 1/3.
Would that be negative 100? No. That would be 20.
1 over 125, but yes. Right? Because 1 over 5 cubed.
Oh.
Does that make sense?
Yeah.
Right? And then that simplifies. And again, it says just write it without negative exponents. So you could literally just circle that. No negative exponents there. No negative exponents there. Right? This, super easy. Expand each. So right now, it's all one term, technically. So we're going to expand by distributing, and that's multiplication. 4t's minus 14. See how it's 2 terms now? We have expanded. Yep.
I don't know. I just took all the time was realizing all this stuff that's just clicking and clicking and clicking and clicking and clicking.
Basic. I told you. They really are. They really are. X times x, x squared. X times 9, positive 9x. We cannot combine those. That's x x's, that's 9 x's. Can't do it.
Why can't you combine that x's together?
Because imagine that x were 5.
Maybe they're different.
Right, yeah, x could be anything, right? So x x's could be 5 5s, and this could be 9 5s. And so you'd have 14 5s, that's fine. But if I had 6, I'd have 15 6s. And see how it changes, right? So we can't combine them. X squareds and x's can't go together. And that's actually a hard one to understand. So I don't blame you for asking that question. That is a little bit trickier. This is more obvious, right? We don't know what t is. There's 14 1s here. There's 4 what's here, right? Could be 1s. Then we could combine them.
Or it could be
2s. It could be, yeah, exactly, right? And we can't combine those. We cannot assume. All right, now let's go. This is going to annoy me. There we go. Let's go over here. This is getting bumped. That's why. Yep. Okay, so factor each of the following. Read directions. Factoring is the opposite of expansion. It's basically taking this and turning it into that. So we have two terms. Turn it into one term. Well, I noticed that they both have a common factor, a number that they both multiply with, 6. You could have done 2 and then taken out a 3 again later, but let's take out the biggest number I can find. See how that's the same as that? I factored it. Again, if you took out a 2, you would have gotten this. And you would have noticed I could also take out a 3. And that's just this. Right? Same thing. Cool. That's it. Over here. You'll notice 7 and 30 don't have anything in common. However, they both have an x in common, right? That's 7 times x times x. That's 30 times x. We can factor out.
Is there a difference?
Yes, because canceling could mean anything. Like, if I add 5 to negative 5, they cancel. They go away. They become 0, right? But if I do 5 divided by 5 and you say cancel, they didn't become 0. They become 1. And that's a big difference, right? Because when you multiply by 0, everything goes away. But you multiply by 1, you just ignore it. If you add 0, doesn't change anything. But if you add 1, that changes things, right? So canceling, I try to avoid that phrase because it's not really descriptive about what's happening. Here we're factoring out an x because they both share a factor of x. Kind of like here, that 12 and 18 both share a factor of 6, right? 6 times something. So they both have that. It's 2 times 6 and 3 times 6. Here it's x times x to get x squared, and it's x times 30 to get 30x. And nothing else in common. So there we go. And this is super useful. This is basically Algebra 2 101. And when you get to more advanced Algebra 2, which is what we're doing now, it's like this on steroids. So understanding this is so important. Over here. Right? This is a single fraction. We need common denominators. See how these don't have the same denominator? Well, what I'm going to do is I'm not going to change the problem. I'm just going to look at it in a different way. So in order for those to match, I'm going to multiply by x over x, so I get 7x in the bottom. Okay? Now, why is this legal? Why don't I have to do it to both sides or whatever? What is x divided by x?
1.
So I'm just timesing by 1. And does timesing by 1 change anything?
No.
So I'm just looking at this in a different way. 6 times x is 6x squared. That's why I did it. So you know how common denominators work. Like 3/4 plus 5/4 is 8/4, right? You just keep the common denominator, right? So 3 minus 6 squared, it's just that.
I always forget that what is game-wise.
Denominator is on the bottom, numerator is on the top. You can just call it bottom and top. I don't care. Words are for communication. They're not for being like, well, that's not the proper term. Who cares? How do you feel about that? Get common denominators?
I think that was my biggest thing in my last one. Almost every spot was written find common
Yep.
denominators.
So let's practice that with regular numbers. 3/4 plus 5/3. One easy way to do this is to times this by 4 over 4, so we get 12 in the bottom, and times this by 3 over 3, so we get 12 in the bottom. Okay? And I did it both, that way they'd match, right? Here I only have to do it to one of them.
And they both equal 1, so it doesn't change.
Yeah, it doesn't change anything, right? So when I get this, I get 9 over 12, and 9/12 is 3/4. It's the same number, it's just a different way of thinking about it, right?
So that'll be 15/12.
Try again, 20/12, right? So a total of 29/12. And that's why it's nice, you can add those together now, because they're all like terms, they're 12ths,
And then,
right?
And they just leave the rest stays like that.
Yeah, it's 29/12. If you could simplify, maybe, but like there's no common factors to divide out. So we got common denominators, and then we're allowed to put them together, however they say. We're minusing. Okay, whatever that is, right? Intermediate. Evaluate when r is 3. Well, whenever you plug in a number for a variable, always wrap it in parentheses. So what we have right now is the root of something squared plus the quantity of something plus 1 squared. And I left a space for it. So when I plug in 3, I don't make any mistakes. 3 squared is 9, not 6. 3 and 1 is 4, and we're squaring that. 16. You can't root these individually and get 3 and 4. You have to add these. This is all needs to be combined.
25.
And then we get 5. Okay?
For B, I have to remember when we take it that it's not, I'm not doing 9 divided by 3 and
Rewrite it like this.
15 divided by 3. Okay.
That divided by 3. And then minus sign means that, hey, separate term, right? Separate term. You're not doing 3 minus 9. Okay? So let's plug in 3. Now you could times that or divide first, doesn't matter. I'm going to divide first, 5. Or 15 divided by 3. 9 divided by 3. Now combine like terms. 2. Over here, whenever we plug in for a variable, we leave a space with parentheses. That should be a plus sign. Sorry, that was a mistake. We're not solving, we're evaluating. That just means plug it in and see what happens. We're not solving for a variable or anything here. They told you S is -4. And it's super useful to use these parentheses because then it makes sure you don't miss the double negative.
I don't like when they change the numbers.
I know.
Like, for one, like, for
The letters.
Like, if there was like another page or two in between, I'll be okay.
Yeah, right after each other.
Too much.
Yep. That can get you sometimes, right? 'Cause now it's -4. Read directions. You'll be fine. Again, leave a space. That way you don't miss the double negative. -4 squared means -4 times -4 because the negative's included, right? So that's 16, and then we negate it. -16. 4 times -4 is -16 minus 12. -32, -42, -44. Cool? Something, again, all over 3. See how they said all of that over 3? So it's S minus 8 over 3, which in other words is this. They said -4 is S. That's clearly, when I put those together, -12. That's -4. Feeling okay?
I think so.
All right, this one. It's all multiplication in the top. 4 times 2 is 8, and that's going to be x to the 8th. Again, do it in any order you want. It's multiplication, right?
Wait. How is that? How do you get 8 from 4 x to the 3rd?
Yep, I got you. 4 times x times x times x times 2 times x times x times x times x times x. We can do that in any order we want. Parentheses don't matter. It's all multiplication. So I did 4 times 2 first. And x times x times x times x.
Oh, for some reason, I was looking at the one next to it.
Oh, gotcha. Yeah, not this one.
No. To the left of the 2 and x and 5.
Okay. And then this stays. Now we're not done, because if you notice, there's some common factors here. I can rewrite 8 as 4 times 2. And I can rewrite that as x to the 4th times x to the 4th. You don't have to rewrite it like that, but I'm just doing it to illustrate. 3 times 2 times x to the 4th. And here I think it's very clear what's going to divide out. Because again, it's all multiplication and division. So let's divide out our x to the 4th and make 1 over 1. Divide out our 2 over 2 and make 1 over 1. And now it's clear to show that what I'm going to get is 4 times 1, 4, times x to the 4th, 4x to the 4th, times 1. 4x to the 4th. You follow me? 3 times 1 is 3, times 1 is 3. Here, let's divide first instead of multiplying. Okay, did you actually see what I was doing here? For real? Okay, you got to tell me when it's off the screen.
I could see the.
For you and for the people at home. So this one. I'm going to not times and get a big number. I'm just going to divide first. 24 divided by 3 actually works out nicely. 8 over 1. Are you following me?
Then that would be, no, 3.
Yep. Right. Cool.
Wouldn't it just be, did I cancel?
8 times 1 is 8. And then t cubed times t to the 8th is t to the 11th, wouldn't you say? Now 3 times t to the 4th times 1. 3 times 1 is 3. And that's t to the 10th.
So you add those together.
Why do we add those together? Because this is t times 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 t. Clearly that's t to the 10th, right? Cool. Now all of the t's except for 1 is going to divide out in the top. Done. Follow me?
Why do you not have a t on the bottom?
T to the 4th, t to the 6th.
No, on the 8t over 3.
Why don't I have a t? Because remember, all of the t's are going to divide out. All 10 of them, except for the one on top, right? Does that make sense, right? All those are going to become 1s, except for the 1 t on the top. Cool? Write each of the following without negative exponents. Yes, okay. So, yeah, I want this one. Right here. So, x to the negative third is the same thing as this, right? So that's just 2 times 1. And x to the 5th times x cubed is x to the 8th, because that's a total of 8 x's being multiplied. Done. This is 4 times, this is divide by, I'll write this. I hate explaining this one. Dividing by this. Okay? So, you can't see what I'm doing. Does that make sense? Divided by that. How about this? How about this? I'm going to times by x to the 4th. No, I hate teaching this. What's a good way to think about this? Because I can tell you the answer, and I can tell you why it's the answer, but I can't tell you without, well, I can't tell you without giving you like a trick, essentially. Okay, how about this? If I divide something in half, it is the same thing as timesing it by a half. So like 8 divided by 2 is 4. 8 times a half is also 4. So do you see how timesing by 1 over 2 is the same thing as multiplying by 2 over, or dividing by 2 over 1? Right? There's that relationship. So dividing by 1 over x to the 4th is the same thing as timesing by x to the 4th over 1, otherwise known as x to the 4th. Does that make sense? Dividing by this is the same thing as multiplying by its reciprocal. Yeah.
Not a nice one either.
Well, there.
This one I had the first day, and then I totally forgot how to do it, and I lost my paper going through.
So
I had all my quizzes spread on my floor in my room, like for my portfolio.
yeah,
And I all got blood with that.
rookie mistake. That's why I take it very easy first semester. We don't take the portfolio super seriously. Next semester we will. You have to make all these stupid mistakes of I spread them all out on my floor, and now I don't know where they go.
How much more seriously?
Now you know when you're doing board work, you can go, oh, I need to remember this for the end of the semester. I should write this one down, right? And you can get organized. Before it was like, I told you to do that, but nobody had any clue, right? Now you do. So, something times something is what we want to write this as. This is something plus itself. Isn't it just doubling it? Isn't this just tripling it? Right? Isn't this just...
So my answer for that would just be 4 times.
Oh God, let's zoom out.
Would just, for like the bottom one, it would just be 4.
Yep.
Parentheses, 2t minus 7.
See how this is the same form as that?
Yeah.
Right? You just need to notice that, look, when I add something to itself 4 times, it's the same as timesing it by 4.
So you're just going to make a copy of these for everyone in the class, or what you said?
I give a copy to you and anybody else that wants them. So,
Each section, are you that how you breaking it down, or is this going to be like one overall?
I'm going to give you literally this. I'm going to scan it.
No. Let me phrase that. For like how you're doing one of these sections for each period, are you giving the paper done in that period to that period, in that period section to that period, or are you doing,
Are we talking about this thing right here?
yeah, or you like one like master copy to giving to like all periods, so like.
I will give this copy to anybody who came tonight because they're here to get it. That's it. Like, I'm not hiding it. If someone wants a copy later on, I'll give them a copy. How many r to the 4th must be multiplied together to get r to the 20th? Well,
5.
yeah, because if we do that, we get 8, 12, 16, 20 r's being multiplied. Clearly, that's r to the 20th, right? That's what 20 to the r to the 20th means. Times it by itself 20 times, right? So 5. Is the following correct? No, and here's why.
What is the thing to the x?
It means divides out, right? It's this thing. Doesn't work because there's not an x in both terms. So imagine I had 15 plus 5x over 5. See how I can divide out a 5 from both of those? In other words, I can factor out a 5 and get this. Are you following me? And now, since it's multiplication, 5 times something, they divide out. Here, I can't factor out an x from both of these, so I can't divide it out.
Because you don't know what it is.
Yeah, there's two different terms, right? So there is not an x in both terms, so I can't do this. Like, this is why whenever you divide stuff out, you should factor out first.
Is what you're saying now, is that how I would explain it?
Yeah. Like, a lot of people want to use this shortcut and divide them both, right? But really what you should do is factor out the 5 and then divide it, right? And see how here you can't factor out an x from both? So you can't divide out an x from both. Doesn't work.
If I have 0 check marks on quiz 3 and 1 check mark on 2, what should I prioritize?
Either. They're both worth the same.
Okay, I didn't know if one was.
Whatever one you're most comfortable with.
I knew one was worth a lot. I didn't know if like one was slightly worth more than the other.
Well, the way things work, unfortunately, is that 1 was basically just quarter 1. And so you take your quarter 1 grade and you add your quarter 2 grade to it, right? And you average them. Quarter 2 is 2 quizzes, meaning that there's 2 opportunities for you to kind of do quarter 2, whereas quarter 1 is just quiz 1, meaning that half of your grade is basically quiz 1. Wish it wasn't like that, but that's how it is. It's the dumb system we live under. So yeah, if you can explain something like this with words, I'm not super picky. If I can tell you understand what's going on here, I'm good. And if you think about it, right, if x were 12 or something, right, 5 plus 36 divided by 12 is not the same thing as 5 plus 3. Right? Oh, those go away. Well, no, it's a completely different problem now, right? 5 plus 3 is not the same thing as 5 plus 3 times 12 divided by 12, right? Suppose t is positive. Simplify. You know how to simplify this. Half power, t to the 6, 2 times 48, 2 squared times 29. Is that right? Nope, it's not. 2 times, I need 24. There we go.
Oh,
Right, yeah. Yep. And then 2 again, 12. 2 again, 6. 2 again, 3. Does that make sense?
Yeah. Then to the half.
Okay, cool. So that's going to be t cubed. That's going to be 3 to the half. And that's going to be 5 halves, which is 2.5. So this. So it looks like 4 t cubed, and then these are both in the half power root, so 6. Feeling okay?
I think so.
Right? This and this makes 5 halves. 5 halves is 2.5, right? 2.5. That's 3 to the first, so when he times it by half, we get this. That's 4t cubed. Those are both in the half root. They don't get out, so it's 6 square root 6.
We're allowed to go back and forth. We're allowed to, like, I know we're allowed to swap.
Yes.
But we're allowed to,
Yep.
are we allowed to go back and forth? on
Yes. Tomorrow is going to be insane for me. I'm going to be running around like all over the place. It's going to be nuts. Yes.
it? Right, about for Wednesday.
Mm-hmm.
Our first finals, our third period. We just go try our third period as if it's like our first period.
I think so. Yes. Right. And I'm ready to go. Boom, boom, boom. 5 to the first, x to the fourth. Done. That one was not bad. If you know 125 is 5 cubed. Right. Simplify each of the following. Oh, you're ready for this. We're minusing. 3x minus 4x is negative x, negative 1x, right? 7 minus, go back to this, 7 minus 9 is negative 2.
How do you get the next x?
3x's minus 4x's is negative 1x.
1x.
Better? Yep. Good. Good question to ask. R squared minus R squared is 0. Anything minus itself is 0.
What, would you get points off if I put 1x?
No. It needs to be negative 1x, but yeah. Hello. We're finishing up this one. Remember, we are live, so just be careful. Live mic. 3r minus 7r, negative 4r. Negative 2 minus negative 5 is the same thing as negative 2 plus 5. 3. Distribute first. 3t plus 21 minus, and I'm going to distribute that t, minus t squared minus t times 9 is negative 9t. Does that make sense? So when I subtract these, I'm going to get negative t squared, because nobody else says a t squared. Again, keeping the negative with it. 3t's minus 9t's is negative 6t's. And then positive 21. How you feel?
Good.
Cool. Factor each of the following. This is quiz 2, Ripley. We're doing intermediate questions. I'm going to make a copy of this when I'm done, so you don't need to write anything down. I will copy it, give it to you. We're factoring. Here are 3 terms. What do all 3 terms have in common?
They're all divisible by 2 and 4.
Yep, so let's do 4. That gets me negative 2t cubed plus t, right? Plus 4. Nothing else in common. I factored it. What do all 3 terms have in common here?
They're all divisible by 9.
They are divisible by 9. So I take out a 9, factor out a 9. Again, that's what we're doing. 3z squared plus 3z. Is there anything else they have in common before we're done? They do. And the max I can take out is 1z, right? So I have 9z on the outside, and I have z squared here, because that gets me 9z cubed, right? If I put it back in, 9z cubed. That gets me negative 27z squared. That gets me positive 27z. Same thing, just a different way of looking at it. Nothing else in common for all 3. I'm done.
I think I have to get going.
All right, go ahead.
I'm sorry.
No, you don't need to be sorry at all. I've got more of these online if you don't watch them, but honestly, there's plenty of stuff here for you to already take a look at. Okay? This is not our attempt to get everything right. It's our attempt to just learn a little bit more. Take care, Joey.
Off topic, my grandma went out and
What?
You said you have copies of the stuff on Wednesday?
Do you want me to copy it for you right now and give it to you? Or do you want to get it tomorrow?
You want me to just get from your home tomorrow?
Yeah, that works.
I
Yep, that works. Bye.
thank you.
Mm-hmm.
okay, off topic, my grandma went out shopping and she bought you a donation maybe for me.
Why did she do this?
What?
Why did she do this? That's incredibly nice, but why?
I don't know. I think it was my grandma Melinda.
Okay, well, that's very nice. We have Clue, Battleship, and Uno.
I have Clue, Battleship, and Uno.
That's very nice.
So, Merry Christmas. Where do you want me to put these?
Thank you. Over there on the game shelf, please. Thank you. That's very kind.
They're not open
Always,
yet.
always appreciated, but also unnecessary.
They're not open yet, but.
I see that. All right, stopping this recording.